Raz. Good morning, ladies and gentlemen. It's the high time to open the second day of the conference. And two leading persons for the whole event, the whole enterprise, have just came here. So the first one, I would ask you to maybe give us a few words of welcoming. This is Piotr Jarnuszkiewicz, the Vice Dean of the Academy of Fine Arts in Warsaw. So it's so great that you host us. And yes, the floor is yours for a moment, please.
Thank you very much. Welcome. I'm a Vice Rector for Academy of Fine Arts Warsaw. I'm also one responsible for foreign affairs and external cooperation. And this is why I'm opening this day today in the Czapski Palace. As you can tell, this is a newly renovated place, academy main core from 1947, as far as I remember. Because before that time, we were placed more on the Wybrzeże Kościuszkowskie. Now there is actually the first building we had in Warsaw in the beginning of 20th century. And of course, now there is the old building and a new one. So this is what Academy is all about the tradition, about new technologies. That's why it's a great pleasure to host you here today. And this is also about the future of cooperation, because as you know, today art, it's also the art with a piece of science. We also leading researchers, not only didactics in academy, not only we are trying to develop new thoughts about what art can be in the modern society. We also are very concerned about scientific research. And as Academy in Warsaw is the oldest and the biggest in Poland, we are having over 1,500 students. I know that regarding the reality of technical universities is not that much, but believe me, regarding the art education, it's a lot. We are having 9 departments. Those departments spread from sculpture, painting, graphic design, interior design, but also restoration and conservation of art, which we are very proud of. And this is the department that very much takes care about the scientific research, and is the place that all those two, we might say, approaches to reality meet, our art approach and scientific approach. That's why, heading to the point, I'm very pleased to welcome you on behalf of our rector, Professor Błażej Ostojalniński, in our academy, which is the fruit of cooperation between Technical University Warsaw, especially architectural department. And here, big thanks to Professor Anna Wierzbicka. It's a great pleasure that we cooperate not for the first time. Now we might say it's a time we're cooperating, and we are very glad that we can host you here so you can be the part of our academy and the part of our approach, and we can also learn from you. What does it mean to work on the piece of something material? Because as you know, various people here work on the materials. My grandfather was a sculptor, and to me, something physical is very important, and the physical contact with reality is something very important. Even though I'm a photographer and cinematographer, I always cherish when there is something you can touch. And the subject of conference that is taking place here is also about something physical, as architecture is mostly, maybe not always, but to me, it's also about the environment, interior environment, and the structure that it's connecting all our senses. So good to have you here. I hope that it will be fruitful for you this time. I'm very impressed by the catering section, which is also very important thing in every conference as it takes place. To me especially, I'm a coffee lover and I saw those coffee machines, so good luck. I think there is something to wait for. And of course there is something to wait for in the meaning of new knowledge. So I will also from my place hearing to that what you're gonna say. Thank you very much. Thank you once more. Thank you, Professor, for this great cooperation, and have a good day. Thank you.
Thank you. And as you, of course, know, to organize such an event, and even a good coffee machine, not to mention the pavilion in the garden, and all the great experts, and this beautiful book, and so on and so forth, is a huge effort. Taken up by many people, a huge group of organizers, who is anyways led by Professor Anna Wierzbicka, so maybe you could also invite us for today's session.
Thank you all to come here. Thank you, Professor Protiar Nuszkiewicz, because he's not only the host of this place right now, but he's our friend, and I think the friendship between fine art and architecture, we are very close. I think in some part we are just working together in all the projects. And I hope this cooperation will last, not only in conference, but also on the field study, on the... I have experienced that a lot of students study fine art, and this is competitive. Competitive and equality, yes. And for me, it's a pleasure to be in such a beautiful place, especially for our friends from Ukraine. I hope changing the place, it's good for you. You can see the Warsaw in a beautiful place. So enjoy and have pleasure in the second day. And I hope what I said yesterday, that the conference will become a cycle and it be every year appear, and we can meet together and discuss about the most important issue about the architecture, design, fine art, and everything which is surrounding us and giving us the future. So thank you all.
So now it's time to jump in the knowledge part. So I'd ask Professor Agata Bonenberg to start with her first lecture. We have, roughly speaking, about 20 minutes for this set. And also, please remember that we'll have a short panel discussion after 3 presentations today. So please keep in mind your questions to Professor Agata Bonenberg and also former lecturers. So, yeah, the floor is yours.
Okay, thank you very much for your kind invitation. Ladies and gentlemen, exploring mycelium-based composites, eco-aesthetics in interior design. In our Institute of Interior Design at the Faculty of Architecture at Poznań University of Technology, we are obviously very strongly promoting and teaching sustainable solutions. We use materials that can be, for example, reused in circular economy. We do a lot to kind of oppose to this trend of fast fashion in interior design. And in many objects that our students produce under our supervision, like for example these glass panels, material is widely accepted, and its beauty and its aesthetics, it's kind of obvious. And in other materials that we apply as a production material, this notion of beauty is not so obvious. And I will be obviously talking about mycelium-based composite, and we have been working with this material for 3 years now, and it became clear to us that the problem of aesthetics here will be of key importance. So the question is, will people accept the material itself, and will people accept the product that is created from such non-typical material? So in order to answer these questions, we have quite fully researched current knowledge, concentrating on material components and growth. And these are best maybe shown into these quite highly rated papers. And then this research was followed by the research on the acceptance level analysis. And all these, in all these cases, the team from Poznań University of Technology worked really closely with our colleagues from the University of Life Sciences in Poznań. And obviously there is a very strong relationship between the acceptance level and material components and growth, as one has an effect on the properties and mechanical properties and looks and strength and so on. And this, especially the first research, was aimed at the data collection to develop and to make more perfect our own new mycelium-based composite. And it is very important to have your own material, your own material to work on, because of the very strong patent protection of the existing material. So what I'm showing you here, it is, it basically means that nearly 27% of the market property of and intellectual property on the mycelium-based composite is owned by the company that is called Ecovative Design. And they, for example, prohibit to test their material on acoustics. So, for example, you cannot create acoustic panels from their product, and you cannot test it, simply because the company knows very well that it's actually a very good acoustic material. So this is why it is important to develop our own stuff. So if you want to have your own material, what is the difficulty? So the first thing is obviously the proper selection of fungal species. There is a selection of the substrate. There is a production technology that also has to be established. And then there is an issue of fungus inactivation method. And obviously the product itself should be first technologically feasible, cost-effective. It should provide adequate physical properties throughout the section of the element, obviously, and it should be acceptable to the future users. So the difficulties in the appropriate selection of these fungal species arise from their very wide variety and the variety of available and possible substrates. So many species of fungi, have a quite difficult to determine inactivation parameters, so you don't know how to stop the growth. It can form mycotoxins. It can attract insects or bacteria. It can become, at the end of the day, it can also become an invasive species itself. So here, in this Voss viewer diagram, it shows the frequency of publication of scientific comparisons of different fungal species. Obviously, the size of the circle shows the popularity of the mushroom in the literature. And we have been studying on this kind of a diagram in order to understand what other laboratories, what other colleagues are doing all over the world. And you can see the three most popular fungus species here on the slide. And we are working with Ganoderma lucidium in order to create our mycelium-based composite. Then we worked in this similar manner with substrates. Obviously, substrates for mycelium-based composites come from three main sources: agricultural byproducts, industrial waste, post-consumer waste. And in terms of composition, they can be divided into annual plants and into hardwood. So the ideal medium here would contain enough nitrogen and carbohydrates for rapid growth. And different substrates are compared in scientific analysis or combined as mixtures in can be very different proportions. And we can see from here that the pine wood is the most widely used wood material, and the fibrous plant with high cellulose content is hemp and cotton. But I must say that it is not entirely also in line with our findings. So we have a little bit different ideas about especially the wood material. Inactivation method. So there are several methods that are used to inactivate the substrate. It can be heat treatment, it could be autoclaving, it could be pasteurization, it can be a treatment with chemical or microbiological agents, and it is all to remove, part is to remove the organisms, other microorganisms. So here you can see the sample that has been colonized by other organisms. And what is even more important, that inactivation inhibits the growth of the fruiting bodies of the fungus. So here you can see the sample where basically the mycelium has created a fruiting body. And here another. And now this diagram, it shows what triggers what is called a telomorph stage. It is the stage of sexual reproduction, usually with the fruiting body, and the anamorph stage. It is an asexual reproduction. Often it resembles a kind of a mold, and what we want to have, what we want to obtain, is this anamorph stage of growth. And this diagram shows that practically when you expose the sample to the light, when you expose it to oxygen, and when there is a drop of CO2 and temperature, then the fungus tends to go into telomorph stage. So this is something that we basically don't want if we want to maintain a regular shape of our sample. So here we see one of the samples that is undergoing this reproduction stage. And in inactivation, it inhibits the repair processes that can be basically happening in the sample. So, for example, if you have a sample that got destroyed, you can put it together, and if the conditions are correct, this sample will grow again together, like it happened, for example, with this in this example. Nutrients. Obviously, the substrate must contain the nutrients required for the growth of the fungus in order to improve the growth rate and to modify and improve the mechanical strength and properties. And here the simple sugars, for example, glucose is very useful, and adding glucose to the material, it results in less degradation of the cellulose at the initial degradation stage. So the material tends to be more durable because we have more celluloses basically inside. Then we really like to have our mass, our MBC colored, and this is an ongoing research, so I'm not going to talk much about it. And altogether we have identified 11 attributes of our, let's say, perfect composite, and as I said, colleagues from the University of Life Sciences in Poznań are developing a number of different proposals of the MBC materials. And then I would just like to add that there are millions of fungal species, and they are still unknown to the science, so it can provide an excellent opportunity to identify fungi with even better properties. And for now, we are working to understand on whether, if we manage to when created, if we manage to actually use it. So it is really crucial to analyze the levels of acceptance. And in the most recent paper that we have published also together with Ania Lewandowska, who is here in the audience, the paper was undertitled Mycelium-Based Composites, Surveying Their Acceptance by Professional Architects. We have focused on professionals holding degrees in architecture in interior design. And the study was a questionnaire focusing on a cohort on 25 women, 25 men, 19 to 55 years old, obviously all holding degrees, who were asked to visually assess 10 examples of mycelium pavilions. And to my surprise, this material itself was fairly unknown, but the 90% of the respondents found that material was visually appealing, visually pleasing, but the least aesthetically pleasing projects were those with MBC was not subjected to thermal processing. So the one that was naturally developing organisms on top was rated worse. So we perceive the ones that are covered with little fungus and bodies and other organisms, we find them definitely less appealing. Our research from, I think, 2 years back, we have also developed and tried to understand the level of likability of a mycelium-based composite in the real environment. So that was not a questionnaire, that was a test. That was an organoleptic test and 2 types of consumer tests. And I will not go to the specifics of the methodology because it is all open access, but we have obtained detailed results. So for example, from organoleptic test, we know that the impression of warmth at the touch is an asset to this material. We found that the softness of this material is also an asset of the material. From the consumer test, we also asked 2 questions. Would you accept the material and interior design elements in your own home? And would you accept the material and the interior design elements in a home that you design in an ecological aesthetics? And we found that, again, the respondents' acceptance to the material is high. Respondents associate the material with ecological solutions. Respondents not necessarily, however, associate their own homes with ecologism. So it is like ecology, yes, but not in my own home. And I think that the last research has brought the most interesting results. It was consumer test following the method of pairwise artifact comparison of wall cladding samples, and these were samples of our own productions. As you can see, the pattern itself was designed by our students, and the comparison was chamois clay, this is the number B, the letter B, and the MBC that were confronted. Here you can see some photographs from the production. And in this study, we have found that, the most important assumption, in my opinion, the respondents believe that mycelium-based composite compared to ceramic is less visually appealing, but it is original, it is interesting, and it looks ecological. So this visual unattractiveness is combined with curiosity, and in my opinion, it indicates this shift in the aesthetics paradigm, the visual unattractiveness being somehow more appealing. And this is something that we have been talking a lot yesterday. So I think it is an important indication, because maybe in the future, as we also said yesterday, instead of associating, modernity with these beautiful, shiny, perfect surfaces, maybe we shall associate the modernity with something that is completely different, that is something more like that. And in conclusions, I would shortly like to refer to the photographic exhibition that is placed close to the pavilion that we have visited yesterday. And its aim is to see the mycelium-produced object in the context of everyday home objects, in the context of home textiles. And the purpose of this exhibition was to visualize what it would be like to include this material in our everyday life. Thank you very much for your attention.
Thank you, Professor Bonenberg, for a great opening. Now it's time for a shorter lecture that will be given by Professor Anna Wierzbicka and Dr. Katarzyna Miśkiewicz, so the floor is yours.
This lecture will be given in cooperation with Łukasiewicz Center in Łódź and Faculty of Architecture. We will talk about our experiment, the pavilion that you saw on the Sunday, and this is the beginning of our cooperation, and I hope it will last. I will speak the second part. So.
Good morning, my name is Katarzyna Miśkiewicz and I am from Łukasiewicz Research Network, Łódź Institute of Technology. I am also a PhD student at Technical University at Łódź, where I'm preparing a thesis connected with higher mushrooms. First of all, I would like to thank the organizers of this conference, Faculty of Architecture, Warsaw University of Technology, to invitation and giving me opportunity to build something innovative, the pavilion of the future. Today, I would like to say you a few words about higher mushrooms. Because in Poland, the cultivation of higher mushroom is very popular due to its ability to grow in very short period of time in many different substrates. The commonly used substrates for cultivation higher mushrooms are, for example, lignocellulose wastes or wastes from agro-food industry. This is, for example, sawdust from these industries, straw, corn residue, and various types of cereals. Higher mushrooms have a wide range of enzymes which favor to decomposition of these types of waste. Rapid growth also makes this fungus resistant to mold and bacterial infection. Higher fungi is informal name given to mushrooms from Ascomycota and Basidiomycota group. They have relatively large sizes, form complex structure and fruiting bodies. But the essential part of the fungus is the mycelium. It's usually hidden in the substrate, for example, soil or wood. And it's formed by a spider web-like network of highly elongated cells called mycelia. Despite of the fact higher fungi fruiting bodies have a valuable part of our diet, mycelium is also excellent material for manufacture of product with significant environmental impact. It's a vegetative part of the fungus, consisting of a number of filamentous fibers that extend out of the fungus. Our team from Łukasiewicz Research Network has tried to take advantages of these properties and create a mycelium-based composite material. At this stage, we can do, for example, building materials, packaging, paper, or biodegradable gardening product. The innovativeness of proposed material lies not only on unique procedure of cultivation of higher fungi, but also in a great variety of possible applications of the produced material. Mushroom-based materials are ideal for replacing non-biodegradable materials used, for example, in buildings, construction, or wall panels. In addition, we use waste from agro-food industry, and we don't generate any waste, so our project is in line with current trends of circular economy. That is, moreover, last year in 2023 we won two awards. First award was the Energy Transformation Leader Award at the Polish Climate Congress, and the second award was a Grand Prix Award at the Demo Day of the Łukasiewicz Accelerate program. That is why we decided to join the initiative to create a pavilion together with Warsaw University of Technology, the Faculty of Architecture, being in harmony with nature. But more about this and process of creating the pavilion will tell you the initiator of this conference, Professor Anna Maria Wierzbicka.
Thank you very much for presenting the first part. When we start to think about building with mushroom brick, we want to look for the partner who will help us to develop this product, because we are not material experts, we are architects, and we think about architecture as a beauty, sustainability, and togetherness. So we researched the projects which were already made by the mushroom bricks. Like you can see on the MoMA roof in New York was designed a pavilion with the mushroom bricks. It's extraordinary project and it's look really fancy and great. You can see scale and how much brick you have to grow to do this. But what you cannot read in the papers and the internet, this project only lasts for 3 days, because then the rain comes, the bricks start to fall. So we can see that designing with the mushroom bricks, it's still in the experimental level. That's why when we start to think about this product, we have to design the shape. I will show you, because we have here some sample. of the mushroom products. These are the samples made by Łukasiewicz. These are the samples that we design. And because if you can see, we designed it with a student. And in the Royal Bus Garden, we have to keep some things which are very important for the garden. So we couldn't design the growing pavilion because the Royal Bus Garden was afraid that the mushroom will grow everywhere. Yes, you can see the mushroom are really, they can even grow on the moon. I don't know if you know that. So we researched for the project, and it's a pity, but this group of students we got from the January. So our team have to design the shape of the brick before we start to work on designing the project. And I will show you there are two bricks, one made out of the mushroom, which we designed, the shape, the scale, and one in traditional way. We are happy that this company gave us, Dąbrówka, this 1,000 bricks for free. We still have them, and I hope we will build something in the future from them. So the shape we have to design, which was handy, and we designed it in a small scale because we think that designing the small scale is better for the architectural way. So after designing this mushroom bricks, we talked with Łukasiewicz. It was really extraordinary experience with us, but Łódź is very close. You can drive there by the train for 1 hour. I really love this city because my family was there, so I always come there with my heart. And we discussed together what the product is good and what color should be made. The professor Agata Bonnerberg talked a little bit about because she is in an experimental way, and I am very happy that another faculty is working at the same problems because we can discover it in a different level. And we chose the blue color. People ask me why blue. Because you will recognize it's a different material. It's not a normal clay brick, but it's a brick made from something else. What is important about this material? If you can see, it's light, yes? And you can transport it everywhere. So if we want to build on the moon, and sky is a limit, in our pavilion you can see, I think it's easy to transport just a little bit of mushroom, just a little bit of water, and you can grow it everywhere. And on the pavilion in Royal Bus Garden, you can see that we made a lot of 12 projects with the student to implement this mushroom brick. But because it's not already tested, we couldn't use it as a fundament, as a waste product, because it'd be dangerous for the people. That's why we put it in the pillars, you can see, and if you go in the Royal Bus Garden, you can touch, feel, smell, and look how it's going there. The pavilion, of course, it's standing for 3 days, and in 1 month, 2 months, we will see how it's working on the air, by the water, and for us, experiment is the best part of the research. So, if you can see, finally, this mushroom brick is like a small part of the pavilion. And a lot of people ask us why it's like that, why it's not a big part. The one thing, we couldn't manage to have more bricks than 100, so it's little small amount. We can just build a wall. But building a wall, it's not example. We want to build the material that it's a part of the pavilion, which is a part of, because architecture is not only a matter of construction, it's a matter of beauty, of sensibility. And you can see that there in the pillars, here's my little son who helped us doing the pavilion. And the problem is that we designed 2 halls to be a construction way, but in the end it became a little bit smaller, so we have to drill it with a Hilti driller to make it a little bit wider. And I think this project worked really well. And on internet yesterday I saw that somebody wrote, go to the pavilion when you can feel and touch the mushroom bricks. Because when I talk with architects, my friends who are not architects, they tell me, mushroom bricks, something like that exists? I say, yes, we have to discover new things, because 200 years ago, nobody will believe that we will fly to be 9 hours in New York. Nobody will believe that we'll be on the moon. And I think trying and cooperation, working together with different institutions, this is the future of everything. This is the future of material, of the space. Thanks to all the students who are here on the audience, who help us organize this conference, who are really hero master of this project, because we discussed with them how to use this brick, because they had already this product, yes? They couldn't find how to design it. We designed it already for them, because out of the time. And the people are really using it. If you're not already follow us, please follow us on Instagram. I can say to my student, really big bravo, because we had only 200 observators, now we have 600, even more, it's 35. And yesterday, during the conference, I came with one of the professors to show him the pavilion. There were just a teenager lying there and talking to each other. And I asked him, from what you know this pavilion? They say, we know it from internet. We want to come here. And they say, here is the mushroom brick, somebody told us. It's fancy, it's nice, it's the future. So we hope that it's a small things, but it shows that we have to look to the future. And I hope to cooperate even wider. Yes, I see that Professor Agata Bonneberg have a really bigger experience in the architectural field of the mycelium. We hope to cooperate with Łukasiewicz because it was really excellent cooperation. We discussed about the shape, how to grow it, how much time, about the color. The color is not artificial. So actually, if you eat this brick, I think you won't die. So this is natural color made. And I hope you enjoy our pavilion. Go there, see the mushroom bricks. One day, with my colleagues, we discuss, my dream is to build really a pavilion with a mushroom brick and see how it will last. And I hope it will last more than a pavilion in the moment. One more thing, last year ago, we organized first conference, which was Rebuilding Ukraine. The impact of this conference was help Ukraine, because we know that nowadays the war is still going on. There's a lot of people who are living without houses, they don't have schools, they don't have theater. And this very cruel situation impact us to join and gather together. Today in our conference there's about 20 of friends from Ukraine. I hope every year they can come and we can manage to host them in Poland, because for us, it's so thanks to Ukraine, yes, that this impact started this conference, and I hope, what I say before, every year we will meet to talk about different things. And the question is, fungi is the future. There's lots of books about it. Some people say, you probably know that in biology, this is another kingdom. I talk a lot in my house because my daughter studied biology, and she said that the mushrooms are everywhere. This is a special net of the earth. They communicate each other, and I think in my heart that this is a future material for architecture. Of course, we have to improve this. We have to work on it to be more dense, if you can see. And thank you all to listen to our speech.
Thank you. Just one brief comment is that a lot has been said by Professor Bonneberg about the aesthetics and the level of acceptance for mushroom. And when I saw the pavilion on Sunday, I thought, well, that's just a little bit of mushroom. It's mostly wooden, but the mushroom plays the role of jewelry in the whole structure. And actually, that's the prettiest element in terms of aesthetics of the whole thing. So that's very interesting that it plays this role in the first place. Well, Michał Gołębieski from the Faculty of Architecture, Warsaw University of Technology, is the next one to share some knowledge with us.
Good morning. Comparing to mushrooms, material which I'm going to talk about is quite old. My presentation concerns biocomposite made of hemp and lime and review of the studies on the effect of the material on energy demand of the building. Hemp-lime composite, which is also commonly called hempcrete, has low compressive strength and low thermal conductivity. Therefore, it is not used as a load-bearing material, at least not often, but it's rather used as an infill or insulation material. It can be produced in a loose and compact form, depending on the proportions of ingredients and density resulting from the manufacturing method. And it may be used to insulate all the external partitions of the buildings, like floors, walls, and roofs. It was developed in 1986 for renovation of historical timber frame buildings in southern France, and was also rarely used to renovate some masonry buildings. It became popular, quite popular, and was also used in single-family houses all around the world, as well as in bigger housing estates, multi-family buildings, public utility buildings, and even larger scale storage, production, and market buildings. In Poland, it emerged in 2011, and since that, number of realizations is increasing every year. Now let's focus on the effect of the use of the material on the environment in the construction stage of the construction stage of the life cycle of the building. Hempcrete is made of hemp sheaf, lime-based binder, water, and some optional additives may be also present. Hemp sheaf is produced from industrial hemp. This plant is cultivated to obtain fibers, nuts, and flowers, so hemp sheaf is a byproduct. It grows thanks to energy from sun, which is acquired in photosynthesis, and the manufacturing of the processing of the material is low energy intensive and purely mechanical. The second ingredient, lime binder, is not that good for environment as hemp sheaf. Extraction of the limestone pollutes the landscape, and burning of lime requires a lot of energy. Also, this chemical reaction is associated with a lot of carbon dioxide emission. Luckily, most of the carbon dioxide emitted when the lime is burned goes back to the material, is sequestrated when the lime carbonates and goes back to the limestone form. There are four main construction techniques using hempcrete. It's stamping monolithic walls, spraying monolithic walls, bricklaying with prefabricated blocks, and assembling prefabricated panels. Because of those properties, hempcrete has a quite low carbon footprint, for sure lower than for traditional thermal insulation materials like mineral wool or EPS. Now let's see what is the effect, what can be the effect of use of the material on the environment during the use stage of the building, and that's the main part of the presentation. First of all, material is characterized by a low coefficient of thermal conductivity, approximately 0.1 watt over meter Kelvin, which allows to construct walls which meet legal regulations in terms of thermal protection and not exceeding thickness of 50 centimeters. Secondly, thanks to properties of the material and properties and the application method, as well as the fact that the material can be used to insulate all the partitions of the building, we can expect that with the conscious design, of course, we can expect that there will be a small amount or even almost no thermal bridges in such buildings. Also, thanks to the compactness of the material and the fact that when it's applied, it sticks to the structural elements, the airtightness of the envelope may be high, which was proven in some experimental buildings. Thirdly, hempcrete has relatively high thermal capacity, of course comparing to soft thermal insulation materials, which may result in lower energy demand because the material can store some excessive heat for later. Of course, it's uncomparable with heavy materials like concrete or ceramics. There's also numerous studies on the heat flow through the material in dynamic conditions. Especially, there was a study by Everard who found out that in case of thermal shock, so when the temperature is drastically changing on the one side of the partition, heat flow stabilizes slower in hempcrete comparing to mineral wool or cellular concrete, which may lead to energy savings. This effect may be significant in some locations in which the temperature amplitudes are high between day and night. In temperate climates, this effect may be less visible, but maybe not negligible. And finally, hempcrete has superior moisture properties, high moisture diffusivity and very high moisture effusivity. It can be classified as good or perfect moisture buffer. So use of this material in the interiors stabilizes the humidity levels, which can affect in reduction of need for ventilation and ventilation-related energy losses. To summarize, hemp lime composite has a potential to enhance timber frame buildings by replacing traditional soft thermal insulations. I will now point out two main advantages. First is aforementioned higher thermal capacity, so buildings may require less energy for heating in winter and less energy for cooling in summer. And the second feature is the property of the material, which enables us to design partitions which are open to diffusion. So water vapor can exit the building, or material can store it for a time being and give it back to the interior. As I said, it may lead to decrease the need for ventilation. Also, it can have a negative effect because moist material, which have a higher moisture content, is more conductive. So there are some complex simulations which show that the final outcome depends on the specific design and on the climatic conditions. For sure, this material helps to provide comfortable, more stable temperature and humidity conditions in the interiors, and we can design walls without synthetic materials, which are now needed for vapor barriers or for wind barriers. Such elements can be, in that kind of design, simply removed. So thank you for your attention.
Thank you. So we still have 15 minutes for this round. So I guess it's not much, but it would be nice to have you all here, all the panelists, on these comfortable chairs. So please join us. That's time also for you to ask. So I will just ask the opening question, and we'll take more from the audience. Like, what I'm really interested in is that still a more experimental research field what you've shown, like what Michał shown was like a little bit with more tradition on this research. But is that the moment that it shall be already a regular element in regular program of teaching you are all teaching at faculties of architecture. So how strongly it shall be already in the program?
I think the program and the faculties and all the academy should be flexible. So everybody can teach what is like it shouldn't be very stable. That's why in a program you have to teach, of course, beautiful, sustainable together. Like it's normal. But in the program, I think we should think about the future and about the climate change, because we already feel that, yes? In Poland, it's not so hot, but there are some of the places in Africa and South America where you cannot live anymore. So thinking about the material, how to grow it, how to reduce CLT, this is the things that we should teach young people. Because this is the future of the world. And of course we cannot change a lot of things, but if we change some small parts, maybe we can change the future. So the education have this point of changing the mindset of the young people to be care of the environment. I think the young people are really they really care about it. They really know about it. They talk about it. Even if they are not from architecture, they are more aware than my generation, for example. So some of the young people, they for example, maybe a little bit not from the architectural field, but they use second-hand clothes, not to buy everywhere. Or that's why I think reduce, reuse, recycle should be as well as making new materials.
We have implemented a lot of materials, a lot of experimental materials within our existing courses of study. So practically without changing much the program of studies itself and the framework of what we do usually, we have introduced, we have been introducing this glass technology as well because of the infrastructure that we got, and we will be allowing our students to work with mycelium composite as well. However, for now we are encountering some difficulties in terms of safety, allergies, things like that we know, and our research also show that the material that we are working with are safe, but Polytechnica is not so convinced about that, and they want to have a deeper look into the safety of the material before introducing them to the students. Well, they are not so concerned about the employees. So.
I would like to share my opinion. Materials like fungi, mushrooms, or hempcrete, or earth, or straw bale, they may look simple at the first look. It may look like a step back, but actually this is a step forward. They look simple, but they are very complex. The physical phenomena which are occurring, chemistry which is behind it, is very complex, biology too. So I would postulate more engineering in architecture studies. So architects not only can, of course it's very important that they are proposing something, but also they can apply it in a way that it really makes a change. So my opinion is that also development and engineering work.
Katarzyna, would you like to add something?
I think that people can't be afraid of new technologies, mushrooms, and so on. We use for example, our technology only edible mushrooms, which you can eat, you can buy in shops. So it's very safe, and we know it because I am a microbiologist too, and we pay attention on safe on the first place.
Okay, is it time to, yeah, there is a question here, so please, you'll be next. I see you.
I have the question, what is the reason of the problem of so little quantity of the mushroom bricks you get for the pavilion? Is it that it was special brick, or there was no producing capacity in Poland? Because I must say that I have seen the exhibition at the, I think, last Venice Biennale of Architecture in Belgium pavilion, where there was many walls made of mushroom. So when I heard that the students built pavilion of mushroom, I suppose that it will be something like that, but then it is just this little jewelry. So what is the reason of the problem of so little quantity?
The reason is the people. We have only a 3-person team. And we do it only in laboratory conditions, so this is the reason. And on the first stage, we have a problem with a supplier of our material, so we must cope with this situation. So,
of course, it's a jewelry, what Hubert said, but we think this is the good start. And what I say, my dream is that we will develop a material that we can build and it be a part of the architecture. Not only a jewelry, not only inside, which you cannot see, but we can feel. So, of course, it was not enough. It was short time, but we have to start from somewhere.
I just want to add that the color of your brick is much nicer than the one in Belgian pavilion, so.
Okay, I wanted to continue this aspect of the jewelry. Did you check the load capacity of this brick? Like, did you start some tests or something like this? Or there's some plans about it? Because it's quite curious how it will affect like on the bigger structure and if it be self-loading.
We don't have a test in environment, but we know now that our material have great mechanical properties. For example, it's 10 times higher than styrofoam, for example, and it is resistant to fire too.
We got only 100 bricks, and we use them. I don't know. So we have to implement this natural brick. So you can look at 2 of the bricks, but we hope to develop, because we have a cooperation letter, to have more time to have more bricks, because 100 is little in our architectural field. And to do some tests, yes, because if you don't build, you can draw everything, you can paper take everything, but you have to build it in reality. And I hope we will do it in the future, because in the faculty there is, I hope we'll start this experimental project and in the different fields. So this is a good idea to do that. And we didn't have time to do that because we were running out of time. So this is the future.
And I will say also that the next step will be buy a bigger mixer, so it will be a lot of bricks next year, I think.
Okay, so one little, it's not too personal, but it's to Agata Bonenberg about, you said about this division between perceiving eco-design at public structures, interiors, whatever, and our own home. So the question is, do you, at your home, have any funky design elements?
Yes, I do.
And is that dot here, or you could tell us what?
No, it is, I have, in my office, I have some pieces of furniture. I have small, like, coffee tables, and I will be completely frank with that. I keep in my office quite a lot of material, and in CAT, it can get a bit like, you can feel, you can smell it when you enter, but there is a lot of these elements there, a lot. But at home, I keep only like 2 or 3 minor like lamps and things like that, and I am not noticing any difficulties in using them. So I think that obviously the technology needs to be improved. Well, that's for sure. But I think it's promising. It's still promising, especially in the interior design where you don't have to cope with the problems of humidity and of. It is a material that in interior design can be easily, I think, used.
We actually invited Professor Agata Bonenberg to show her work, and if you go to the Royal Bus Garden, you can see in the exposition there's the things that were made, and really excellent. They look, I think they are very fancy, so we are very happy that we match together on this field and to develop. So if you visit once more or you are not know, you can see the work of her team.
Okay, would any one of you ask about something, or we can just have a break? There is one question, so we still have a moment to take it. Yes, go on.
I have a question regarding the mycelium. It's dealing with the living organism, and every piece is unique in some way, but how do you achieve the repetitiveness in it?
The bricks, all bricks are different because the mushroom, even if we put it in the form, it's very difficult to gain the perfect shape. Yes. So this is the answer.
For us, the beauty is on imperfection. It's like Japan way. You know, the Japanese, when they break some cup, they glue it with gold, and they think it's more beauty because we are not perfect. We get old, we get wrinkles, we get fat, and this is beauty as well. So for us, this variety in this brick, it's not a bad habit. This is the good feature. So beauty is on imperfection.
I also want to add something. Of course, it's true, but in terms of engineering, it can be a problem, especially when you cannot repeat the same properties. And it's a problem in terms of legal regulations. If we don't have a product which has the same properties all the time, we cannot use it on a mass scale. And it may be a problem of mycelium, it is a problem of hempcrete and any other material of biological origin or something like that. So, but I think because we are ending our discussion, there will be a topic in the next or panel number 6 or 7 where this problem will be discussed, how it can be utilized on the larger scale because of this not repetitive properties.
Okay, so I guess now it's time to have a break. The schedule plans for a pretty long one, 45 minutes, but the networking is a really important thing of any conference, so yeah.
Brooklyn has now like become almost more synonymous with New York than Manhattan in a way. Yeah, everyone like thinks of Brooklyn. Jay-Z and the Yankees and the Bronx.
That's true. The big part of culture, yes. Ladies and gentlemen, I hope your coffee and your chats and people you met, it all made a good experience for you in this break. Now it's time to jump into the knowledge part 6. And our first lecturer is Anders Berensson from Stockholm, from Sweden. He'll talk about resources from a local context perspective. So, Anders, the floor is yours.
Thank you. So thank you for inviting me. It's an honor being here. My name is Anders Berensson, and I run this Stockholm-based practice called Anders Berensson Architects. I'm also a teacher at the KTH School of Architecture in Stockholm. We do a wide range of projects, from commercial projects to private projects to public projects, but we also do these sort of more collaborative projects, as the one you might have seen, for example, at the pavilion, the future pavilion, but also doing this sort of future speculation projects just for the fun of it. So today I'm going to talk about wood buildings, hands-on experiments to politics, planning, and also even science fiction stories. And as I said, we do all kinds of projects, but why I'm going to talk about wood is basically since I'm from Sweden. So if you look on this map and you see this sort of dark green, you see that sort of that I'm actually from a giant forest. And the most easy renewable building material to get in Sweden is, of course, then wood. So the first project is called Outdoor Office. And this project is about how do one make use of the whole wood pile, and also how do you make your own ketchup, in the sense that I think Swedish architects have a tendency to buy ready-made products too much and not sort of like going into detail, actually sort of making your own details and so on. So the first project is an office for an outdoor company called Lundhags, who make these sort of boots. So the top floor is their office space, and the floor below is an outdoor space for outdoor gatherings, lectures, and also a starting point, just to go out hiking in the woods. And speaking about this, speaking about wood as a material, I think wood has this sort of capability of both being structural and insulating at the same time. So when talking about making your own ketchup, why do we even buy wood windows, for example, when we can just place the glass directly into the structure? So these are the kind of things I mean by that. And that's sort of the advantages of wood, that is sort of very easy to handle on site and adjust on site as well. So here's the top office space, here's the space below where you have sort of these outdoor gatherings. And of course, in the winter, it's just snow going in. Once again, making your own sort of ketchup, not buying these typical brackets, but actually, designing them yourself. This is just to honor the owl that lives there, and also to sort of tell the ones in this meeting, that you might be joined by the owl. Also, in a typical Swedish building, also a wood building, 10% or 5% is calculated waste. In this project, we said that all waste materials will be the interior. So the interior you see is actually the cut-offs from the building site. So you can see the beams that are cut off are made for tables. The roof truss, for example, you see the angular one there becomes a chunky furniture, and also the leather is from the shoe factory. Next project, how do you harvest the tree? And this is a project called Chopstick in Indianapolis. And this project started off with no limitations, being in an art park in Indiana. So we decided to work then as sort of, to have some limitations, we decided to work as luxury chefs, sort of asking ourselves, what would a chef do if they came to Indiana? They would probably look for the best cow or, you know, a vegetable or something, and then sort of slaughter it in the best way possible. So we started to look for a building material in Indiana, and we found this sort of yellow poplar tree, which is a giant tree standing on the fields of Indiana. And there's hurricanes going through Indiana, but this tree still stands, so we thought this must be a perfect beam. So that was sort of our starting point. And then our question was then, talking to loggers, how can we harvest this in the best way possible? How can we slaughter it so we can, you know, get the best meat out of the wood? So first thing, to slaughter a tree in a nice way, you actually cannot break it while chopping it down. So lifting it with a crane, quite complex, but we could afford it. And then chopping off the rotten parts, making tables out of it. Since we were chopping it down in May, the bark actually loosens from the trunk, so we could use the bark as a facade material, then transporting it to site, and then using this sort of giant beam, but taking parts out of it to build the structure for the house. So some parts, for example, nice part of wood is made to make the window, for example. Other parts are made for the structure. And we even was able to produce some syrup out of the building also, so we could actually eat part of it. Seeing your pavilion yesterday, I thought I would talk a little bit on how we do pavilions in KTH, and also connecting them to wood. So first question is maybe how do we harvest an existing wood building? And the second question in this course is like, who owns the city, who gets happy and who gets pissed when you start building? So first thing in the course is actually I take the students to a house that is about to be torn down, and we help them take it down. So we harvest usually a summer house. It's quite a dangerous thing to do, but still every student is alive. And then we tell them improve the city. So we give them some sites in the city, especially sites where maybe the municipality owns one part of the site and the government owns one part of the site, or the traffic institution owns one of the site, and so on. So there's usually a conflict in the site. And then we tell them, build something nice and see how people react. So here's a bench. Here's a staircase, for example, for a park that's meant to be public, but now is used by the harbor. So testing, you know, just testing to build stuff and see, are people getting happy or are people getting angry? And if they get angry, you can always remove the things. If they get happy, yeah, then they get happy. Yeah? We also use this sort of, when we take down a building, we discovered that the easiest way to use a building is to make a smaller building, basically. Furniture or smaller buildings, because usually you take down the timber and you sand it down, and then you can use it for smaller objects. So this is a tiny building we built with the school, insulated by sheep wool. Also private clients that we build like allotment gardens for. I can recommend you who are doing this course that never work with private clients and students, but we tested it at least. So making small buildings in Stockholm out of reused wood. I also want to talk, how do one avoid making a wood building? Because making buildings is not always the best thing. I think as an architect, you should always ask the question, do we really need a building? This is a project for an outdoor company called Fjällräven in Sweden, which sort of trains, I think they have shops here in Poland too. This is a conference center where the people from Fjällräven people comes to Sweden and get trained in the Fjällräven sort of philosophy and products. And we were asked to design this sort of conference center. And the first thing we noticed in this old barn was that we couldn't, when people started walking in the barn, it was too loud, so people started complaining. And then the second thing was that people could not sleep here. So the CEO actually from Fjällräven said, then maybe this is an opportunity, because the worst thing with conference is that you go there, you get drunk in the evening, you sleep in this sort of air-conditioned hotel, and then you get home. So you always sort of leave the place with, angsty, So we said, let's take this Swedish culture and maybe emphasize it a little bit more, and we can do these things with this sort of outdoor, we can improve this house with outdoor culture instead. So the first thing is that the guests take off their shoes, as you do in Sweden, and you put on soft shoes instead. And then we didn't have to sound insulate the building, so it's way cheaper to do this than actually to rebuild the house. And the second thing is that they get a backpack and they get a trapper. So they go out in the woods instead, and they camp, and they use the Fjällräven product, and get a good experience, and they fly home, actually being in a tent, using the backpacks, and they're not hangover either. So this is a good way to not build something. So you can see, the drying the stuff after the night. We do proposals for Stockholm. We help the sort of center neoliberal Green Party. I'm not part of the party, but I've been their consultants for free elections now. So we agree on some things and disagree on some things, but I tend to sort of push in what we agree on, and that is to densify Stockholm and to densify it with wood buildings. So every election, we do this kind of like wood scrapers out of CLT, and I think this one is even 10 years old, so then CLT was kind of new. Now it's an existing thing in Sweden. Also proposing dense wood skyscraper cities. Every chance we get, basically densify Stockholm, even if we do public buildings, for example. This is a strategy to place out saunas in Stockholm, or making it more walkable, the city more walkable. We try to do it in wood and try to densify the city. So yeah, small public buildings in the city center of Stockholm. This is saunas and sport facilities. When proposing to use wood, one should also sort of question a little bit, what is it that I'm actually proposing? And how does this Swedish forest industry, work? So we did this sort of future speculation project for an exhibition up in north of Sweden, where we started to dig into how does actually the Swedish wood forest industry work? Talking to a lot of researchers, getting very vague answers, also understanding that most of the researchers are actually paid by the Swedish forest industry. Looking into asking easy questions. What happens if you log an area? And it takes a long time to understand, for example, that it will emit greenhouse gases for 15 years after being logged. Most of the Swedish forest is actually used for non-renewable products, papers and so on, that will sort of be burnt quite immediately. Making, for example, this black liquor that's sort of used for biofuel. And in a sense, yes, it's a renewable resource, but around 50% of Sweden's carbon dioxide emissions is actually coming from the forest industry, but are not taken into account because it seems as renewable, but you can really question if it's renewable. It also takes 60 to 120 years to regrow the forest. You should also know that these sort of long-lasting wood products, if you chop down a tree, around 20% is actually used for wood. The rest is used for burning. With that says also, climate change has made storms taking down trees in Sweden. So for example, we had a hurricane in 2005 taking down 75 million cubic meters of forest, which is actually 1 year of harvesting in Sweden. So one can also ask, question if it's sort of are we really in control over the Swedish forests, or is climate really in control over the Swedish forests? So having all this research, but not really having the answers, we decided to do this sort of childish scientific sci-fi story about what we think is necessary for Sweden, which is a central bank of timber. since we're not in control anymore of the harvest of Swedish forest, it will be harvested by bugs, by storms, and by fires. We need to save the timber that's in Sweden, and we made a bank that holds 1 year of harvesting from the Swedish forest industry, which is 1 by 1 kilometer structure of wood. So this is a science fiction story you can read more about, but here's the bank. Okay, and my last project, Tibro train tracks, which is basically 2 projects. How do you detect and harvest a local resource? So this is a city planning project for a small town in Sweden with about 5,000 inhabitants. And it's made in 4 phases. So the first phase is basically a citizens' dialogue, trying to find out what do the people, and this has been going on for about 3 years now, and we're about to start building projects. We built 1. So phase 1, we were asked to start this dialogue, to make some inspirational pictures so we can start talking about, and we said that's maybe, instead of just making 1, let's make 60 fast montages to sort of get people speaking. So these are the montages, just asking, what do you want to do in Tibro? So it's like, do you want a zoo? Do you want to drive your motorbike here? Do you want an art place? Do you want to ride? Romantic park, sports, waterfalls, selling furniture, race cars, circus, Eiffel Tower, Lord of the Rings, pub, tulips, land here, cozy place where you can hug people, savannah, skateboard, beach volleyball, charter hotel, fountains, gardens, waterfalls. Maybe you just want to, go to the toilet. Chicago, snowmobiles, so on. Then showing these images and having a dialogue through the main events in Tibro, also then giving them these sort of postcards where they can draw and they can write what they want in Tibro. We got 300 answers, and then we divided them into sub-genres. So, for example, you can see here that the green is park activities, public park activities. The red part is suggestions of different buildings, and the blue part is suggestions of different transportations. So we use this to form kind of a visionary plan. So this was the first stage. Second phase, meeting factories in Tibro. They do a lot of furniture manufacturing in Tibro. Looking at, what can they actually, what are they good at producing? What are their machines? Is there leftovers that we could use? So for example, here we got this sort of, we found 6,000 of these ones that they just had a leftover of, if we could use that. Talking to politicians, but also the bold guy has, the digging machines in Tibro. And then from that sort of mix, doing 15 sketches on what can be produced in Tibro that Tibro wants, and that Tibro can produce by themselves, and also then maintain themselves, and also probably produce for a cheaper cost. First project we did was we got this free caravan, and we used one of the factories that sort of sprayed this black powder to make it into our office, and then we worked in Tibro for half a year through this caravan, meeting some people, not only seeing, what they written down on these postcards, but actually, talking to people, and then using these very tiny budgets that are in this small town. So this is the Christmas coziness budget for 500 euros that we made an entrance to the park. And then we started with these connections. So for example, one guy wants to build a market hall, and we said, let's do a market hall, but let's use these 5,000 ornaments that are in no use anymore, and let's make it into this sort of Tibro market hall. They also have a craft academy focusing on gilding stuff, but also on fake marble painting, carpentry, and so on. We suggested let's do an all-in project with them, just just maximize that school. Using the leftover railway parts to make this sort of gravel pit where one can, just have fun on the countryside. But also, simple projects like making a square where the one who's blowing glass sits in that house can make sort of the lamps for the square. Working also with, this is in Tibro, they do this sort of, when you cross a red light, you push the button. They make that one in Tibro. So, and they don't have any red lights there, it's a small town. But we said, let's use these ones to program public spaces. So instead of, crossing a red light, just, push a basketball and you have a basketball field or a football field, a playground, or even a romantic park. So the fourth phase then is to actually start building these projects. So the romantic park is in a very early stage. It has this thing on, and we have some lamps, but we don't have any trees yet. This is hopefully coming. But then rock stage is this project that we talked to the craft school, and maybe in connection to your pavilion, how can you sort of make that sort of collaborative thing be outside of school, use it in a professional, more like, as an office. So we worked with this sort of craft school, and they said, we cannot give you everything, Anders, but we can give you the fake marble painters. So we've been working with them for 3 years almost, just sketching together how could we make this sort of the biggest marble stage, marble block ever. The first sketch was this, to sort of like make this the most expensive rock ever. Didn't work out so well. It becomes, this kind of pizzeria interior, but it's a great balance. Continuing working on, it's a super cheap project. It's a 30,000 euros project. It's made out of wood, but we're trying to make it look like stone. Different sketch process. We finally come to the conclusion. So these are the drawings. Some is marble, some is actually just parts of meat that we put into the drawings to make it even look more like marble. Prefabricating stuff with the students. Making a tiny wood building, but making it look fatter so it looks heavy. So you can see it's like it's over-dimensioned. And then start, prefabricating and marbleizing the structure. So here's the finished result, and I think one of the good parts with this process is that it's actually been something that's been asked for by the public in Tibro. They asked for a stage, they got a stage, so it's well used, but it's also made by people in Tibro. So when there's graffiti on it, you can always put, someone goes there and they put some more marble on it, It's easy to maintain, it was cheap to do, and it's made by Tibro. Okay, thank you.
Thank you, Anders. This marble thing is really crazy, yes. Another lecture, yes, please join me in inviting Brian Edward Wennerstone from Winterswijk, I guess, from the Netherlands, who tell us about the Dutch Bamboo Foundation that he worked for and lead, I guess. The floor is yours.
Thank you so much. It's a pleasure to be here. Thank you. It's my first time in Warsaw. It's a beautiful city. So I'm invited to speak a little bit about an untraditional material in design and construction, especially here in Europe, and that's bamboo. Picture a pavilion made with a lattice from a plant that is typically used in a tiki bar, but is so intricately woven that it's able to provide structural support along with the elements of the actual full poles and the splits, and that would be our bamboo pavilion called the Trilix. I'm privileged to have partnered with the New European Bauhaus Festival. The festival was in April of 2024, so just a few months ago. As part of the Dutch Bamboo Foundation, we came together with designers and builders, and we put together this pavilion. So a photographer captured this picture here of these young men looking up. And I'm kind of like, okay, I have to get a closer look and see what they're looking at. Straight up to the heavens. So this is what we ended up doing for the European Commission. We're proud of our work there. A little bit about myself. I studied sustainability management at Columbia University in New York City. I was there around the same time as Arthur. We had not met, but it's a pleasure to meet you now. You're at Pratt, I understand, yeah? As an undergrad, I studied environmental and business economics. I grew up around design and construction, so I had architectural plans in front of me as a child. I was on construction sites quite frequently. Actually, my last name, Wennerston, is of Swedish ancestry. So I think maybe that's where the family got into timber construction. So it's a lot of the construction that I was around was stick and frame buildings, so residential and commercial using trees. So that's what I am used to. I also am an accredited professional of the U.S. Green Building Council in leadership in energy and environmental design, and was once in my lifetime taught at the Center for Architecture in New York City about green building practices. In 2017, I left New York City and moved to the Netherlands. And there, I settled down. I married a beautiful Dutch wife. I moved there for love. And then COVID hit. And I was kind of thinking, like, what am I going to do now? Everything was shut down. Everything. So I was kind of like, all right, well, I feel like I just need to start putting plants in the ground. And that's where I started just planting bamboo and researching bamboo. This untraditional material, I kind of went back to my days of teaching in New York City, where I taught about energy, water efficiency, what type of materials are used in our buildings. And a lot of times when I taught about rapidly renewable materials and suggested bamboo. But back then it was kind of like, okay, we can do like bamboo floors, we can do some engineered bamboo, and just have it as a decorative type of aspect. But here in the Netherlands, I kind of got stuck on like, can we use this material in Europe? So I started to explore this. The main intent was to try and create something from biomass, or use something from biomass that can capture carbon as a long-store carbon product, like timber. But I started thinking, like, okay, in the Netherlands we have a quota to build 100 houses per year. The housing industry was also shut down around like 2020 because there were carbon quotas. All the countries in Europe agreed that we were going to reduce our carbon footprint. So one of the ways Netherlands decided to do that was to lower the amount of steel and concrete being used. And the solution that a lot of people came up with was to use timber. So where are we going to get all that timber? Maybe Sweden. But then Sweden has its own quota for housing, and Britain has its own quota, and France and Poland, and everybody needs to build more. So I'm thinking like, okay, we need a little bit of an alternative to timber. I love timber. It's a great material, but we need to mix something else into it. So bamboo was, again, where I looked at. I started by planting just several species in the Netherlands to explore. Turns out that actually bamboo grows quite well in the Netherlands. So there are some pioneers that have started growing bamboo in their botanical gardens as aesthetics, not necessarily to use for design and construction, But here is the Green Prince, he's known as. But he's been growing bamboo for 20, 30 years in the Netherlands. So you can see here, his bamboo is about 15 meters tall. When you compare it to the tropical bamboos, it's not as large, it's not as big, but we can find uses for it. So it grows in the Netherlands. Not the best climate to do it, but here it is. So I started to explore the structure, the biological structure of bamboo, and how can we grow it and propagate it. It's based on a root system that runs horizontally and then shoots up. So bamboo is a rapidly renewable plant, where timber, we just discussed how it takes 60 or more years to mature a tree forest, whereas a bamboo plantation can be matured and harvested within 10 years. But you don't harvest or clear cut the whole thing. You harvest about 30%, and then from these root systems, it remains strong and shoots up new poles. So I started just really basic, part of our research. So getting these little cuttings, putting them in planters. It grew within the first year, so they start off quite small. But the root system gets stronger, and it starts to shoot up the next year after that. So you can see it starts off with a small culm, and then within a few days, it actually grows about 10, 20, 30 centimeters. In Asian and equatorial countries, tropical areas, it grows up to 1 meter a day. Here in the Netherlands, 10 centimeters a day is quite fast, I think. So from there, I was thinking I needed more space, so I got myself a little tiny tractor and started planting it in these boxes. There's a stigma about the root system spreading. I don't know if anybody's heard about it, but people are upset when their neighbors plant it as aesthetics in their garden and it crosses over. So I was being wary to contain it. But it grew well. So this is recently, as you can see, it's starting to raise up to the sky. So the advantages of bamboo is that it does grow a lot faster than wood. We need more materials. We have these huge quotas to build. Our population is increasing. We need housing. We need structures. We have to think about how to sustainably develop our environmental areas. So we think bamboo can be one of those materials, one of many solutions. Concrete and steel have high carbon emissions. Bamboo actually is a very good carbon sequester. I think in Europe we might be able to do about 12 tons of carbon per hectare once the plantation is fully matured, so 5-10 years. So I want to talk a little bit about architects that are currently using it around the world. So we have some great architects that are experimenting and raising the bar of how traditional pole bamboo is used as a material. Unprocessed and used structurally and kind of really pushing the limits. So first is in Bali. Laura Hardy of Ibuku Studio. Her architects there have put together this incredible structure called the Arc. It was recently done, I think in 2022. This is a recreational facility for the Green School. I had the pleasure to visit, and this is the outside of it. The engineer on this is Atelier 1, based in UK, and they are quite excited about how they are able to play around with this new material. So this is kind of like the traditional bamboo renaissance that's going on right now. But you know, it's kind of like, okay, well, it's beautiful, but are we going to do this here in Europe? Possibly, but there's some limitation. But this is Vo Trong in Vietnam. a beautiful welcoming center. Just incredible work that people are doing. 42,000 pieces of bamboo went into this structure. But you also have an up-and-coming architect here in Warsaw. Kika, I had the pleasure to meet at the European Bamboo Expo last month. She just finished her master's degree at TU Delft, and her thesis, her master thesis, is on developing bamboo structures in Colombia for the safety of the community, primarily, actually, for women. Her plan, she put together kind of a step-to-step plan to enable women in different communities to develop these structures within the city limits themselves, actually. So she gave them instructions and ways to do it. She interviewed about 30 constituents and asked them what they're looking for, and this is what she came up with. So keep an eye on her. She just moved back to Warsaw. She's not here today, but she's actually speaking at Bouw met Bamboo in the Netherlands, so we kind of switched spots. But here in the Netherlands and Europe, what are we going to do actually with building with bamboo? I think it's probably more in like the square and rectangle that we're kind of used to, and probably using engineered bamboo. This is Hotel Jakarta. The picture is from 2018. It's in Amsterdam, actually. So it's primarily built out of engineered bamboo. But our challenges here in the West are building codes, it's regulations, is it fire resistant, what is the structural integrity, is there a local supply chain? I think we're getting a lot of the bamboo from either China, that's primarily where it's grown. We get some good bamboo from Colombia, some bamboo coming out of Uganda. There's also a skilled labor shortage. So there are some challenges. But with some of the innovations that we're seeing now, you can start to engineer and have useful products that are capable of being not necessarily a substitute for wood, but perhaps an additive to your project. Laminated bamboo lumber, bamboo reinforced cross-laminated timber, so it's actually, we started using cross-laminated timber to start building up wood structures. We've seen wood skyscrapers go up about 20 stories, and you could possibly increase the strength of the CLT with bamboo interwoven. Even traditional oriented strand board, kind of like the chipboard, you can use bamboo parts for it. And then we're starting to see kind of the next generation of composite materials. So bio-based composite materials will be released soon. So one of the projects that I started working on in 2022 was in collaboration with ArtEZ in Arnhem. It's a university design and art school. They were heading up a research project to see if we can feasibly create a European bamboo supply chain. It was to identify bottlenecks, develop solutions, collaborate with nonprofits and other academics. So I had the honor to collaborate with them as a nonprofit organization. But you can see on this map, again, kind of what I talked about. Bamboo grows the greatest around the equator, but you see some spots starting to come up within Europe. So where is that? That's probably Spain, Portugal, France, Italy, Georgia, Turkey, Greece. So these are climates that are actually showing quite a bit of potential to set up some plantations, and they're already starting. So to set up a supply chain, it's going to take a huge systemic change. So first is we don't want to do any harm, right? We don't want to harm the farmers, their livelihoods. We want to find land that is degraded. Bamboo actually grows quite well on degraded land. Lack of nutrients, it doesn't matter. Bamboo starts to grow nonetheless. It's a very durable plant. So this is a plantation actually in Portugal, and you can see it's starting to pop up. We also have a lack of processing of bamboo in Europe. So we need to start to create the machinery, we need to create the locations to be able to do so, to create the high quality products at the standards that we demand. And then there's product development. There's a lot of companies that are already starting this process, and there's room for more. But bamboo can be turned into many, many, many different uses. And then it's integrating these products into our design and construction and starting to use them a little bit more. But it's going to take collaboration. It's going to take the regulators to be able to come around and say, all right, this is just like as timber is now being approved for use in higher rises, we can start to integrate bamboo within that. So there's testing, there's research, there's studies that are being done on structural elements of it. And the plant can be fully used, so we can find ways to use the leaves in tea, we can use the fibers in clothing, we can use the poles to split and laminate, but there are many, many uses. We can even use the shoots for food. The strength of bamboo is quite good. It's not quite as good as carbon fiber, but we can create the future of carbon composites and have quite good tensile strength. But overall, the properties of bamboo are very good compared to other materials that we're currently using. And the future of bamboo is probably going towards these biocomposites. So I linked Bambooter. They're based out of Amsterdam, and they are trying to finish up a patent on pulling out the short fibers and the long fibers of bamboo. I think the short fibers are good for use in kind of 3D printing, where we're starting to see a lot more innovation there, even in structures. But I think their long fibers is the next step, and they're weaving them together into kind of like a yarn. So this is a little bit more on the project that we just did in Brussels. This was the end result. Once we put the lighting on it, it kind of just painted it, and it mixed in with actually quite well with the curvatures of the architecture behind it. This is in the center of Brussels. So the process, we actually had a problem with the supply chain of bamboo. We're going to use a very good structural bamboo called guadua, but that comes from Colombia. So you can imagine the carbon footprint of shipping from Colombia is quite large. And we really wanted to see if we can cultivate within the European region. So this is actually the bamboo forest that we found in the Netherlands. We were able to cut down part of it. As you can see, we have these 3-meter poles that we were able to use. And then we had to actually manually process the bamboo, which was quite a painstaking process. So it took a lot of effort, but we were able to get strips. The next step is to kind of develop a bamboo model. So as a lot of architects that are using bamboo in their construction, they swear by using the model. You can actually just use bamboo skewer sticks to be able to build your model. And it actually is a pretty good representation of how your actual structure might stand. From there, we moved our prefabrication to Brussels, and we started to put it up. Again, this is probably like 90% materials are bamboo, and then we had some elements like the foundation, the ballast of steel and stone. So we got our master carpenter. He's a German guy, but he lives in New York City also. And we pulled him out of the Bronx to Brussels, and he helped us, a team of 10 people, build this. So the structure, over a course of 5 days, was built in the park and slowly came together. I think people were walking over in the beginning, and they were kind of like, well, we looked at your rendering, and we're not quite seeing it yet. And after a few days, people started to make comments and say, all right, it's starting to come together. Yeah, maybe this isn't quite up to the safety standards, but we did what we had to do. And it's made of these 3 towers. So we had to kind of interweave everything and bring it together. Yes, there is some duct tape there, but we got rid of that. We didn't need it in the end. And it held together really well. So we believe that this structure probably could have stood for the whole summer. It's untreated without a roof element onto it. So just like any wood type of product, it is susceptible to rain, UV, and the elements. It will degrade without protection. So ideally, you could put a roof skin on the top, and it will last for 10 or so years with maintenance, maybe longer. So I want to actually call all the architects, engineers, designers to action and see what you can do to mix in timber and bamboo into your products using, and mycelium, using more bio-based materials for a life ennobling economic system. Thank you very much. I really appreciate it. Thank you very much. And let's connect. This is my LinkedIn. I don't know if that's spelled correctly in Polish. Is it?
Yes.
Okay, good. Thank you again.
Thank you, Brian. Okay, let's skip to another lecture, which is prepared by 3 collaborators. It's Jarina Onufriw, Halina Lukaszczuk, and Magdalena Duda. And Jarina is the one who will present for the group. So the floor is yours now.
Dear colleagues, I'm glad to speak here today. And my name is Jarina Onufriw, as they said. And our presentation is called Landscaping as the Newest Ecological Material in the Urban Environment. The contemporary urban landscape is transforming profoundly as the imperative for sustainability becomes increasingly prominent. Within this context, the urbanized environment needs to improve living conditions for its inhabitants from the point of view of ecology and comfort for people. Landscaping can be considered a new ecological material with high ecological characteristics, contributes to the improvement of the microclimate, and has a positive effect on psychological state of people, which is confirmed by numerous scientific studies. This presentation is based on the analysis of existing experience of applying greening in the architecture of the cities of Berlin, Germany, Warsaw, Poland, and Lviv, Ukraine. So the first example is from Berlin. It is the outdoor vertical landscaping. The accentuation of the main entrance to the building, to the public building, with the help of vertical landscaping. Here, the metal frames were used, and the plant which we used is Wisteria sinensis. And in this building, the plantings are playing the role of decoration, flowering and green accent of main entrance. The next example is also from Berlin. It's quite typical, and it's also here the greenery is used for the accentuation of the facade of the ordinary blocked residential building. Here the plant which was used is Hedera helix, and it has the function of decoration and also cooling of the building. And the main decorative feature is the green mass of its plant. It's a very famous example. I think everybody knows it. Yes, it's the green wall as a structural element of the entire facade of University Library in Warsaw. And here also the metal frames are used, and also without the frame, just on the wall. And a lot of different plants are used here. And the plants are, their function is decoration, cooling, and the green mass of the plants is the main decorative feature. It's also a very common example. These are from Lviv, when the green wall, the end wall of a residential building, is covered by a plant, and this plays the role of camouflage and cooling the building, and also some construction can be used for that, like a plastic mesh, or without any frame, just on the wall. Another type of landscaping which is used in architecture, mass architecture, is horizontal landscaping of rooftop gardens. And this is the example from Lviv, Ukraine. Yes, it's the landscaping of the terrace of Ukrainian Catholic University for recreational purposes. And here they used sedum carpet system technology, and the plants which were used here, the sedums, the cereals, and others. And it has such a decorative features like flowering and individual green accents. Another example from the same complex, but from another building. On that terrace, they used container gardening, and as you can see on the pictures. So it's just another construction and another plant. This example is from a residential apartment building. It's called the City of Grasses because it has green rooftops. And here they used sedum carpet system technology and container gardening. And this functions like for cooling and energy saving also. Another example from the same residential complex, but it's the landscaping of the rooftop about the underground parking lot in the courtyard of that complex. And here they used lawn roof with elements of geoplastic relief. And the function of this greenery is absorption of rainwater and also recreational function. Another example of the historical building in Lviv is this one. It is the example of the garden on the roof of an attached garage to a historical residential villa. And the construction is the lawn roof with elements of geoplastic relief. So they planted their pine trees, as you can see on the picture, and just alone. So this is also the famous example of the landscaping of the interior of public buildings, the terraced landscaping in the interior of the Golden Terraces shopping center. But I would rather name it not the Golden Terraces, but Green Terraces, because it's quite green. And here the construction which was used was the system of phytomodels and also containers. And the plants which were used are the tropical indoor plants. The main function is the decoration, recreational, and ecological. Another example from a shopping center, but from Lviv, is the Victoria Gardens shopping center. And here the plantings are decorating the vertical elements, yes, the columns in the shopping center. And here the construction which was used was the mixed system. And another example, using the greenery like a green screen. It also functions like a decoration and ecological. And the usage of phytomodules, it is the green wall in the interior of the medical clinic Leodarm in Lviv. And also container gardening in public buildings interiors. Yes, it's also the pictures from Ukrainian Catholic University, and it is used for decoration and recreation. And our examples only partially reflect landscaping used in modern buildings, and it represents commonly used technologies. But even these few examples demonstrate how popular, ecological and aesthetic these materials are. And different technologies of architecture landscaping are used for different needs. In particular, within this conference, we have seen some innovative green materials which can be used in architecture in the future. However, for the use of landscaping in mass construction, in particular during the reconstruction of Ukrainian cities, it is important to think through and develop such technologies that would be inexpensive and easy to care for plants. So, thank you for attention.
Thank you, Irina. So, like, compared with all these super top experimental things, here we have what is really already common, which is like a good conclusion here. And another presentation prepared by Yuri Kryvoruchko and Jarina Voronich. And Jarina will be presenting, so please, Jarina, it's time for you.
So hello everybody. That's a big luxury for us listening about material, because Ukraine is under a devastation war. So a lot of people are just lost their houses, and it's even luxury for us to see a man between 20 and 60 on a street, because young men in a street in Ukraine very rarely can be seen. They are either in a war or they are in a house avoiding to be drafted to the army. It's also luxury to see a plane in the sky. So everything it's so amazing for you guys to be normal, for you talking about this things. And hopefully this expertise will be useful for us in the future. But today we hope to survive the genocide that has been going on in Ukraine. So my presentation will be more about urban planning, because a team, the next slide will be about team from all over the world that came to Ukraine to help us to avoid big special errors that can happen when the money might flow back to Ukraine, because right now no one invests in Ukraine. We do not think about materials. We're just being in your environment and feeling that one day we will come back to a normal life. So the team that you can see on the slide came from United States and Europe, and they came during the wartime to a small Ukrainian town, around 25,000 of people that have 25,000 of residents, to help us to avoid special errors that will happen when the business will come back to Ukraine and parachuting us a different type of objects in rural area or in breaking our urban structure. So the next 3 slides, you will see the instrument that we use. It's a new urbanism that is very modern all over the world, fully adopted by Ireland and partially adopted by different countries. And I would say it's a common sense urban planning instrument, because it shows that with intensity, from the rural to the core of the city, a changing intensity and changing the structure of a city. So just moving the next 3, and I'll go forwards and backs, and you will see how the rectangle is moving. So the characteristics, it's a land use, building types, and the front and private frontage and public frontage, which shapes the street, and land. The green belt and open spaces are changing with increasing the intensity from the rural to the core of a town. So this is the change. And sorry, like this. Six urban zone we're identifying, and to avoid the ecological burden on less dense territory, and so these 6 main zones was identified. And so the first zone is untouched natural areas with no development. The next zone is sparsely populated rural areas with farmland and large lots. And the next zone is low-density suburban areas with single-family homes on large lots. And the 4th zone is moderately dense residential areas with a mix of housing type, including townhomes and the small apartment building. And the 5 and 6 mixed-use areas with higher density, combining residential and commercial use, and the highest density zone typically featuring high-rise building and a wide range of a commercial, cultural and social function. So the next slide, you will see the traditional neighborhood development and conventional development. And so this is how we are putting a narrative to the drafting. And so this is how this is going to be in a legislative, when we will work on a master plan. This is how the layout of a street is supposed to be, analyzing the town. And so now we are just looking for Zolochiv. as a town and how we apply this instrument in Zolochiv. So Zolochiv, the team consists of not only urban planners and architects, but also anthropologists. So the anthropologists made a survey of citizens, and the citizens showed the desire that they wanted to see their city pre-1939. So this, you can see the Google map of this town. Then the town was divided into 3 zones and was analyzing and defining our core and defining the code of a city. And because the problems were being identified in the Soviet period, and historic cores also have a lot of problems because Soviet time destroyed a lot of buildings, historic buildings, so they have to be renewed. And the new areas has to be built. This is what I said before. We have a challenge of adopting a lot of IDPs people. And so the problem will be with intensification of the territory. And here you can see the types of the building of Zolochiv and the historic core, the Soviet period time, and a sprawl of Zolochiv. And then the circles shows that the identification of the territory that has to, the sum function has to be strength, and the possible development centers and how to be improved and help communities to build their community. So this is the parks, which is also one of the layers according to a transect analysis. So this is how they define the code of a city. So it shows how the city code has been identified according to pre-1939. This is a new development, how it's suggested to be built according to the code of the town. And so this is closer the new development according to what was identified to be built. So, and then the next steps is very important to analyze this town and implement this analysis to urban codification that is going on in Ukraine, which is very important so we avoid a lot of mistakes in the future. Thank you very much. I try to be short.
Thank you so much. Now it's time for the last lecture in this block. Gennady Ferenyuk and Anna Trifonova prepared it together and will present it together. So the floor is yours.
War. And about the actual problems, what need to decide now. These military tribal problems in Ukraine now a lot. But our blocks have limited timetables, and my colleagues Anna, with her correct English, is doing presentation, and I answer your questions.
hello everyone. Thank you for inviting us for the conference. And today I would like to talk on how to obtain building materials from military origin waste, and also to share our institute experience on assessing buildings damaged by explosions and proposing the best solutions, best technical solutions on how to restore them. The war affecting Ukraine for the past 2.5 years forces us to reconsider not only humanitarian perspective on life, but also engineering tasks and evaluation criteria for buildings and structures created by society. Over the years of full-scale war, Ukraine has lost about 210,000 residential buildings, of which approximately 27,000 are multi-apartment high-rise buildings. Our institute's primary task is to determine the levels of damage caused by explosions and to assess the possibility of further use or demolition of the buildings. And in each case, an optimal decision should be made regarding financial investments and social losses or the continued use of the building, especially when it's partly destroyed and residents may still use the intact part of the building. And we would like to share a couple of examples of what we did in the Institute. A missile hit and exploded on the 7th floor of the 26-story building, and as a result, the tilt of the floor of the intact upper levels was up to 20 centimeters. Based on the measurements of the structural parameters, a post-explosion mathematical model of the building was developed, and the model established that the overall spatial rigidity of the structure was sufficient to allow the possibility of people staying in the intact part. Consequently, the decision was made to dismantle the floors above the explosion site and proceed with the restoration of the remaining part of the building. And as we see, the plan was successfully implemented, and residents have since returned to their homes. A missile hit the 18th floor of the 24-story building shown on this slide, and the explosion's energy destroyed the internal walls and floors of 3 levels, and the tilt of the upper level floor was up to 2.5 centimeters. This enabled the development of technical solutions to strengthen the structure of the upper levels, while dismantling on the floors of the 3 destroyed levels. Next slide shows a 16-story residential building in Chernihiv, where the upper floors of the one section were fully destroyed by artillery shells. The Institute experts have inspected the building and developed technical solutions, and the building was restored. Next slide, here we see the missile explosion in a 9-story panel building in Oman, resulting in the complete destruction of the entire section of the building. Restoration was carried out using technical solution that involved the panels typical to those which were used originally, but these were not the 380 millimeter thick expanded clay concrete panels. Instead, 120 millimeter thick reinforced concrete panels with ETICs were attached to the existing intact panels. They were attached with proven chemical anchors, and on the next slide we see the reconstructed building, actually. Evaluating building for the effects that were not anticipated in their design requires us to solve the new problems which are outlined on this slide and which we can discuss with all of you today. One of the new wartime tasks is the necessity to use construction debris generated during the destruction of buildings. This debris amounts to tens of millions of cubic meters and accordingly tens of millions of tons. And the creation of non-regulated construction debris landfills is one of the components of ecological disaster that already affects Ukraine. Processing these debris and utilizing existing recycling technologies also requires solving many problems. The debris from the destruction of buildings due to military explosions varies in size and geometry, from small fragments to massive parts, with diverse mineralogical composition, including concrete, brick, wood, glass, plastic, metal, etc. And TNT and missile explosions with chemically active fuel result in different toxicity levels of the debris. Considering the variety of plastics and polyethylene and polystyrene in apartments, the combustion products are highly toxic and are absorbed by construction debris, especially during fire extinguishing. And therefore, before processing the debris, it's necessary to determine their safety level based on the explosion source and the results of this explosion. And furthermore, many low-rise individual houses have roofs made of asbestos cement sheets, and this issue should be addressed as well. The issue of recycling and reusing construction waste generated by military destruction should only be considered after a thorough study of composition. Upon a positive conclusion, especially in case of the absence of toxicity, it's possible to determine the class of structures made from recycled debris, establish their intended use, and set the requirements for its safety and safe processing of new construction products. This requires conducting relevant studies of the physical and mechanical characteristics of products made using military construction debris, depending on the type of destroyed building or structure. And of course, this all should be made according to regulations, which should only be developed. And standards and new regulations should be developed to regulate these technical parameters and manufacturing of construction products containing recycled waste. And it is worth to know that there are two branches in Ukrainian legislation, one of which is national branch, and national standards that has been developing for over 30 years in Ukraine are now in effect. And there is another branch with European standards, which is also in effect in Ukraine. And sure, this brings to some conflicts between these national and European standards, which should also be resolved. Under the initiative of UNDP, we are currently developing a waste management concept for debris resulting from military aggression. And this includes assessment of the quality of debris, specification of main types of waste, development of catalog of construction products that can be manufactured from recycled waste, and providing recommendation for legislation changes. So that's what a short overview of what we are doing in the Institute, and while you have any questions, we'll be happy to answer. Thank you for your attention.
Okay, thank you for this lecture, and we are actually right on time, so hope you'll have interesting chats and conversations and possibility to ask questions during the break, the lunch break. I would just take advantage of this moment to give you two important announcements of things that are waiting for you. So for those of us who remember yesterday's lecture by Maciek Kaufman, who talked about the newest terrific park spot in Warsaw, which is Warsaw Uprising Mount, like around 15 minutes by bus from here. Maciek will wait for you tomorrow, Wednesday, at Bartycka 26 Bartycka Street, on the opposite side of the street to Castorama store, that's like difficult to overlook. And he will give you a guide as an author, one of the authors from the authorship group of this park. They got all the most important prizes this year for best architectural design parks, whatever is to be taken. They took it. So if you want to see the place with Maciek, join him tomorrow at 7 p.m. And another short announcement is about another mushroom pavilion that is built right today, right at that moment, by another group of students. So we were watching for the whole semester what you guys did with the pavilion, and at the same time we are doing another one. So for those of us who are interested in mushroom pavilions, too much of them maybe, on Thursday will be the opening of another one at Plac Pięciu Rogów Square at Chmielna Street, and it will consist of over 500 of packages of mycelium. Then within a week they will all bloom with pink eatable mushroom. So too much mushroom, I guess. Anna said that mushroom is everywhere, yes. But it's good to cooperate and have this synergy between all the teams and all of you. So thank you. It was a pleasure for me to lead this part, and have a good rest of the day. Thank you.
Oczywiście. Ja nie wiem, to chyba jest wszystko już... Zobacz, zapytaj, zobacz.
To ja się tak pytam. Przepraszam, czy ja coś muszę wiedzieć, że coś naciskam, czy nie? Tak? Czy coś włączę?
Raz, dwa, raz, dwa.
A, działa po prostu. Super, dobrze. Tak.
Za mównicą czy...
Tutaj siedzę sobie.
Pani jest moderatorem,
tak?
Okej, dobra, dobra.
Okej, dobra. Okay. Hello, everyone. I would like to start the next session. Please welcome our speaker that will go first, but I have to explain the changes in our program first, because Oleksiy Vostrikov was not couldn't cross the border, and we wanted to have him with us online, but unfortunately, because of the electricity blackout, it's not possible. That's why we have a couple more minutes for the discussion, I hope. And our first speaker will be Przemysław Woś, co-founder of Świadom Architectural Studio from Warsaw, Poland. The floor is yours.
Thank you very much. And I am also a member of Polish Association of Natural Constructions. First of all, thank you to be here. It's an honor to be among such great specialists, and I hope that for everyone here, the climate crisis is obvious, and the part that in this crisis takes the responsibility of the building sector is as high as almost 40% of the CO2 emissions. Only the concrete has like 8% of the CO2 worldwide. So I wanted to show you some alternatives for the concrete. And fortunately, we had already some samples of some bio-based technologies already. But I wanted to show you some that are not in development stage, but are already applied on buildings. So mainly, we have a range of natural materials at our disposal. And in the southern Europe, we have like materials like rammed earth or light clay, which is more suitable for warm parts of Europe. In the seaside regions, we have seaweeds and seashells that we use in buildings. But in our area, region, we have mainly two materials that we use. The one is one of them is straw, and the other is hemp. So we have several ways to use straw in buildings. These are two of them. We have the prefabrication method, which is more industrial and more suitable for public buildings. And we have the infill on site, which is mainly used on the single-family houses, but also, but not only. And there are also the straw is used also as a blow-in infill. It's like chopped straw, like cellulose. and fiber boards like made of straw, like wooden wool, like Steico boards. But these options are more interesting, and this is just I don't know what level of knowledge you have about straw, but this is a simple straw used almost directly from the field, which is just in bales, like these cubic bales or the round bales used mainly by prefab producers. And we have hempcrete. This is a mixture of hemp, lime, and water. This is the short version. We can mainly use it as bricks, which is very practical. It's because it's already dry. As an infill in formwork, or sprayed on the wall on the facades as insulations. So, who was the first? Like more than a century ago, there was a French architect, inventor, that started to apply this technique in Europe, in France. It was just after the First World War. And a method for simple, affordable building technology was needed, and he suggested to use straw, which was on fields directly and affordable for everyone. But unfortunately, the concrete sector was more attractive for the governments. But this house is, he built like 5 of these houses, built like just the way we do it today. It was a wooden structure filled with straw bales, as you saw on this picture on the right here. And this building is not only standing till today, but we were there like a few years ago, and we saw now it's headquarters of the French Straw Bale Building Association, and it's thriving. They just opened education center just behind a training center just behind the house, this house, and it's evolving, and it's quite nice to see that after 100 years this building is not only still standing, but it's really good to go 1 century longer, I think. As I saw, and the straw in this building is a perfect condition. It was because it was one of the first building. The inventor didn't really know what to expect from this building, so he mounted like a tube in the walls to get rid of the mold or the eventual animals living in the straw, but with a gas. But fortunately, it wasn't never used, and straw just defended itself. Yeah, and I wanted to show you a scale of this building. That there is no. Yes, there's almost no limit. Like we can use straw and hemp in all these buildings that we can build with wood. And this is one of the biggest in Europe till now, because bigger are on a stage of construction now. It's a school complex in Paris that has like 9 classes of preschool, 15 classes of school. It's for 650 kids. So it's a quite big building, and it was done with prefabs. So the structure, the construction is in wooden construction, timber frame, and it's isolated with straw prefabs. This is, for now, the highest, but as you can expect, the situation is there is an evolution on the market of this building. So I hope that very soon we'll have higher buildings. This is a 7th floor complex of 2 buildings. It's on the eastern part of France. It was a structure in CLT, as you see on the picture, cross-laminated timber. And then the straw prefab panels were used only to isolate the building. This is an idea of the building that was that the ecological aspect was not only in the material used for the isolation or the structure, but the whole installation system, the way they used sun as a gain of energy in winter, and they also had systems like gaining electricity from the elevator going down, or the temperature from the water, the used water in the water system. So yes, and the one which is built now in it's in Sweden. It has 12 floors, and it's interesting. It has a granite basement because it has a smaller carbon footprint than the concrete one. So when it will be done, I hope I will tell you more about it. This is actually one of my favorites, favorite buildings in France, made with straw. It's the first experience which has the city of Rosny-sous-Bois. It's on the suburbs of Paris. What's interesting is that just yesterday Paris extended the subway line that you can go by subway to this town on the suburbs, and you can see by yourself quite a bunch of strawberry buildings there. So this was the first experience for this city. It was a preschool. Now it's a school. They wanted to make it as ecological as possible. Of course, they use not only straw prefabs, but also a bunch of natural installation, like natural ventilation, like as you see, photovoltaic panels, and on the roof they have vegetable and fruit garden, which is a real one, and it's really used by the kids, and we went there and we saw it, and as you see, the plants are growing quite big, and this is very active. So this was also the first project in this city, so they invited all the community around to participate in this construction. So it was more a social, not only a construction site, but also a social engagement or attraction even for the local citizens. And this experiment was so great, and that you see here on your right, there are some buildings. Oh yeah, I can show you like that. And this was an old market which was not used anymore, and the city thought that, oh, okay, so this was a success. Let's expand this idea and be more bold. So in these buildings, here you can see the school that I showed you, and in this there was some existing buildings of a market, and they decided that they will build this same idea of school just next to it, extend this idea there. And the architect said, oh, okay, there was an energy put it in this building already, and even if it's a concrete one, let's keep it. Let's work around it. Let's use it in our project. So they did an extension of that building, and what you see on yellow, these are straw panels building, except this one on the front. And this was quite, they tasted new things, more and more bold, as I said, and they tried the load-bearing technology. It's where straw is used as a structural material. So this part is done without the wood, without pillars, without wood in the walls. And that's quite common technology in Great Britain. They build buildings like 2-floor building at least. But in France, in a public building, it was I think the first time they did it. So that was, and also you can see these like chimneys, towers almost. It's also a part of the natural ventilation of the school. So that was also a success, and I won't show it today, but they built 3 of this kind of buildings more just in the city that has like 45,000 inhabitants. So it's a lot, and that's interesting because they on their website, the city, the most proud, the criteria that they show on the front are, for example, their green areas or the number of associations, NGOs they have in their city. It's a thing that they're proud of. So this activism is very present in this town, and an open mind, and that's why the situation of natural buildings is evolving very fast. So as I said, if you are in Paris, you can go there by subway. Another building that we have the pleasure to visit, it's in Great Britain. As you see, it's a absolutely modern building. It's the medicine veterinary faculty. as I remember. And this was also made in prefabs, but these prefabs were done in a flying factory not far from this university. And the straw came just at the end. You can see here at the end of the street, there's a field. It's which from the straw was taken to make these panels. So it was very, very local. And, and the price for this facade with isolated in straw was like 30% less than a conventional one. This is also in Great Britain. It was an approach of linking, like in a philosophy of building in the housing for people, not only the materials were important, but also the structure, which was a cooperative and a financial context of this project was very interesting. This project was shown in the very famous architectural British TV show Grand Designs. I don't know if you know it. And there you can see the whole process of this group of people that decided to live together, and how they managed to create first this cooperative, and then to during the whole process of building. These are prefabs made. It was made by a British producer, and it's like, as I remember, 20 houses, apartments there in the different sizes, plus one common building for reunions and meetings and cooking together. It's here. And this was, I think, done. This picture was done in the first year of after this project was done, and I was there, like, I think 6 years later, and we had the feeling of entering like an Eden, like all the plants was so grown and it was so colorful, and the atmosphere was very, very nice. The wood went gray, but except that everything was really evolving. It was very interesting. So, as I show you, most of these buildings were done in prefabs methods, but Germany, with their leading architect in this technology, Dirk Scharmer, they had another approach. So they built this. It's in Lüneburg. This city has already some straw-bale projects done. This scale. So this is here. This is a complex of two houses like that, buildings like that. It has, I think, about 40 apartments there, and it was at least isolated with straw by the people from the future inhabitants of these buildings. So you can see them here. It's the Queerbit association, let's say. And so they built it themselves, and also with a lot of volunteers from whole Europe. it was quite easy and very nice that for them to have this impact, to have this role in the process of building their own house. It was so it was kind of it was an association, so they could build this house a little bit cheaper than the standard developer. And also they have some common space, some, like you can see by the plan that they think about the space inside the buildings a little bit differently. That was also interesting to see there. But yeah, focusing on the technology, they built these external walls, at least, by themselves. They put the straw inside themselves. And they're very proud of it. That's a very small but quite interesting project, because it was done by the Henning Larsen studio. And the story behind it, it was that yeah, the school needed some more classrooms. And some parents that was familiar with the straw bale technique, they thought, yeah, let's build it with straw. But they get finance for that with one condition, that a famous architectural studio should make the project. So they were looking for a studio, and they went on, our friend actually, there went on his bike, went to Copenhagen, and there was going door to door to find a studio bold enough and brave enough to make this straw bale extension. And finally, Henning Larsen agreed, but they said that, okay, now we will do it under the radar, because we don't know this technology. And if something goes wrong, we will deny that we have done this. And if everything goes well, then we'll, of course, sign the project and be proud of it. So fortunately, yeah, the funny thing, it was that after they did this project, this is a studio that makes huge buildings around the world. And after they did this small extension of the school, it was the project that they talked the most on conferences, interviews, articles in newspapers. So now they're doing a project of 30,000 square meters of a building made of straw. So, and yes, and this is very, very nice. And as I said at the beginning, that in different parts of the world or in Europe, we can use different local materials. And in this school, actually, they have ventilation in the walls with seaweed filters, because seaweed is very accessible there. There's an abundance of this seaweed on the seashore, and they use it to make or isolation or here filters for the ventilation there. Okay, but not only straw, we have also hempcrete, as I told you at the beginning, and these are some examples. There is this terraced eco-housing in Swindon, in Great Britain, which is also made by one of the main investors, let's say, was Kevin MacLeod. It was the architect who presents the Grand Design TV shows, the one I said before. So this is a very simple terraced housing using as an inspiration the local scale of the buildings and the origins of the area, which has an area with trains, rails, community. I don't remember how to say it, but yes, this is a scale, this is a local scale, and this was what was interesting, is that it was a participative way of making the project, and the future users, habitants of this houses could take part in the process and being informed and explained and have their input in the way these houses were done. And as you see, also this ventilation system was simplified here with this like almost like towers ventilation systems here, and so all natural, no mechanical. Oh, and last but not least, magnificent city hall in the Netherlands, which was that was an idea that there was already a city hall from the 80s there, and they needed it was too old to renovate, and they needed a bigger city hall. So one idea was to dismantle everything and build a new one. But they saw that at more or less the same price, they can do it in a more ecological way, taking consideration the carbon footprint of the process. So indeed, they dismantle the old city hall, but preserving the whole concrete structure of it, and to preserve the elements that they could in the building which they were dismantling. And they did the extensions of the structure in wooden structure, and they did the isolation with hempcrete. As you see here, usually the hempcrete on the facades are covered with clay or lime, but plaster. And here it's like raw, naked hempcrete. It's not a very good idea to leave it like that for because of the weather, but it's covered just by a very slim layer of like transparent vapor. They can breathe. Breathable paint, just with a little bit of color to preserve the wall from the UV light, but yes. So they are very sincere, like very clear with the materials they used. Also, not only to make the building as it should be. I mean, in our criterias that like taking consideration the carbon footprint, but also to show the people, to interest them about the materials that were used in these buildings, that we can build differently, and that we should and do it, and to be like a role model for the citizens. They use the city hall every day. And so they bring back some of the elements of the old building in the interiors, and they also implemented some boxes like nests for insects and for bats or birds in the facade. So that was also a sign that we are not alone on this planet, and it's good to have a relationship at least with the ecosystem and not to treat them as enemies, but try to cooperate with them. Okay, thank you for your attention. I hope that at least I could change a little bit the story about three pigs and their houses. That the straw and hemp houses can be durable and impressive, and yes, thank you.
Thank you very much for taking us to this really inspiring trip to different solutions. And I think that the last example was really the greatest one, because it's the thing that we want to really push, to have the public buildings to show people that they can build in this type of solutions. So thank you again very much. And I would like to welcome the next speakers this time, the team, the strong team. Anita Orchowska, Agnieszka Chudzińska, Somia Hassan, Omotara Adebayo, and the team will present contemporary possibilities for the use of reclaimed wood in interior design. Please begin.
First thing, I would like to thank you very much for possibility to present the work today. And I would like to say that this presentation were prepared by Agnieszka and me, and also two students, which take into account the reclaimed wood in pre-diploma projects, which leader is Agnieszka. Idea for this paper was born during our interior design project, which I lead with Agnieszka. The aim of the paper is to present the possibility to use the reclaimed wood in the interior design, which due to innovative processing method now is becoming a relevant element in the sustainable aesthetic and functionality of residential and commercial spaces. We want to show a few challenges and examples how to use the reclaimed wood in interior design projects. We decided to use the theme of conference, the materials for future, and introduce this subject to the students of Faculty of Architecture English language semester. And we're focusing on the topic of modern material, not only in the theoretical way, but also the practical and real interior design. So the theme of the conference and the theme of the project of the students, it allowed to use modern materials such as algae, mycelium, and of course reclaimed wood. Here you can see some project of the second year, fourth semester of the interior design class, Warsaw University of Technology, Department of Architecture. Students had to design the small commercial space, approximately 60 square meters. And they had to create a clear and very strong idea, and then to solve the functional elements and to come to the interior, to the details. We noticed that not all students just take on account the reclaimed wood, but the most part of them, yes. So they use this reclaimed wood in the structure, in the finishing material and furnitures. So, the wood was used in the form of the cladding walls, flooring, countertops, tables, shelves, beams, etc. So we just have to back some information that according to the World Bank Group, the world generates approximately 2 billion tons of municipal solid waste, of which wooden accounts for 5%. So the modern technology offers different opportunities to reuse this material. So reclaimed wood is just air-dried wood that remains after the demolition of building built with virgin timber, or can be reclaimed from the other and different structures. It has its own history and also personality, and its use adds a distinctive and unusual character to interior and all the buildings. The reuse of wood contributes to the reduce of negative environmental impact by reducing the carbon emission, and offers unique aesthetic possibility reflecting modern trends in architecture with respect for the nature. Here you can see the comparison of facade D with using the reclined wood and new wood. We can clearly see the differences of these buildings. Materials as reclaimed wood used in interiors create a new opportunity and the challenges for the designers. The first thing is that the wood is in the line of ideas of sustainability and the new European Bauhaus, and also reclaimed wood changing meaning of this material. It was used as it's a waste material, but it comes to be full materials. And also reclaimed wood introduced a completely new aesthetic to the interiors, can be also combined with different materials for the new challenges of modern solution. And compared to the new wood, reclaimed material is like to be more variable. And also the use of the reclaimed wood can help architects to find, especially young architects, find their own style, and at the same time it can impose a way of thinking from the very beginning of the design. So the mic is yours.
Thank you. So first, challenges with using reclaimed wood in interior design. Of course, there is limited availability, and we should know at front what source we want to harvest the reclaimed wood. Often that wood requires some repairs because it's damaged. It has reduced lifespan, so we have to check if it's still available to use, and may contain some pests, such as beetles, termites, or chemical containants. So what I wanted to say that everyone at first see that only the challenges, and people are lazy, let's face it. So they don't want to use reclaimed wood because they have to think from where they have to get it. So, but during our work with students, we noticed that there is now a lot of producers that are selling ready products made especially from reclaimed wood. So it makes for us, designers, much more easier to design in more ecological way. There we have two main sources of reclaimed wood. It's old barns, factories, and warehouses. And as you can see, there's a screenshot from first website I found where they offer especially wood from barns. It's another one, it's rolled ties, and it's second most popular source of wood. But in that case, we have to be very careful, because some of them have some special components of chemicals that can cause cancer. And now I would like to show you the companies we found that offers you ready-made products that you only have to type in the Google and just order. So here are some, of course, the most common office producers that are showing us floors from reclaimed wood. We have specially made doors from reclaimed wood. Even we have the place where it's producing only countertops to the kitchen from reclaimed wood, but it still can be used for another places in interior designs, like doors or windows. So, of course, furniture, and I think it's a special niche now on the market that is full of places where you can buy specially designed reclaimed wood. And even you can use some small pieces of wood and combine it with some other materials and make some kind of art, like Japanese designer. And don't forget about ceilings. It still has very hard, very strong expression. The panels on the walls, you can see even it's you can find the price. So and beams that looks much better than the fake ones that we can find in interiors sometimes. So it's still fake, that beam, but it looks much more better than the one from other products. And tiles, but here we couldn't find some interesting companies that are producing ready-made products for tiles. Yeah, so to sum up, I would like to say that there is really a lot of companies that you can find that will that you can write in your design and make it easier for the clients to use in their stores, in their interiors. And it's not like you only write in the design that it should be made from the reclaimed wood and leave the problem to the contractor. So it makes us much easier to use, and that's why we wanted to propose this to our students, to show them that they don't have to use only most common materials like ceramics, like just paint something in one color, but we wanted to make them used to something that is reclaimed, that is already used once. Here is the design of our co-worker of the presentation, Sumaya Hassan. And she designed a cafeteria with art exhibition and used just ready-made panels on the wood that makes very strong impression, and that panels, because in the interior we have art that is changing. We needed something that will bind together the whole interior, and especially because there was 2 stories, and that reclaimed wood, because it has very characteristic view, very characteristic. It looks completely different than anything else. Could be the thing that bonds together all the design. Another one, that's the sushi bar, and here the authors, Paulina Cholewińska, Gabriela Wężyk, and Tomasz Nikoniuk, designed the space made from railway beams, and they designed the system of the fast food sushi bar, that you can use the plates that are here, take on that some food, place them on the height that it's the most suitable for the customer, and then take it back. So, and there was some other technical solutions that I can't show you because we want to register it as a patent. So, and we want, with Anita, each project try to register as an industrial patent to show students that they can protect their work, their authorship. Here, another design is a bookstore, and the students used old windows here. Maybe the visualization, it's not clear, but they aim to combine the facade from the most common sizes of the windows. And the last one, last design we wanted to show you, it's the authors are Julia Malitka, Zofia Poniatowska, and Dominik Schmidt. They were inspired by a church in Gdańsk, which has very specific interior, where all the ceilings and walls are white, and flooring and furniture is dark. And they were inspired by this and used reclaimed wood on the counter here and floor to show that contrast, and made some mystic mood of a cosmetic store. Okay, so conclusions. There are some points that we wanted to show you. What we thought that it's important when we want to use especially reclaimed wood. And the most important thing is that not to think strictly about dimensions, but only about the scale, about some ranges that you can use to make possible on the construction site to search for the elements that will fit there. So designers have to have some open mind for the changes that can happen on the construction site. Yes, thank you very much.
Thank you so much for showing us so variety of solutions that we can have in students' project, but I think that it can inspire the professionals as well. And the last paper presentation in this session will be Wooden Architecture Computation
computational manufacturing. Ewelina Gawel, Agnieszka Wardzińska from Warsaw University of Technology.
Ladies and gentlemen, dear distinguished guests, first of all, I would like to say thank you to all the prelegents, because that's a real honor to be a part of that event and to be in the to be one of the speakers of that conference. And for now, we may say that most of the prelegent was focusing about natural material for architecture, which is obvious, but we are thinking about the advancing way of searching. And sometimes this advance is about manufacturing, but not always. Sometimes we are using typical manufacture, but in very advanced way of thinking. And this is about this is our today's speeches of wooden architecture. And because the professor Maria Wierzbicka mentioned at the beginning of that conference that the future is in young people's hands, I would like to give leadership of that presentation to my diploma students, very talented and full of passion in science, Agnieszka Wardzińska.
Okay, thank you. Oh, no, sorry, I broke it. Yeah, there we go. Okay, so as we all know, the notion that wood is one of the materials for the future is nothing to argue. We can, I think, all agree with that. The fact that it's sustainable, that we can use it in circular economy, that it has an overall appeal. The popularity is growing, and it's rising fast, but is the global forest area rising also? Probably not. We think that we need to use timber as a building element in a rational way and in a responsible way, and maybe treat it as a natural material it is, and include the whole process of its creation into the process of our design, and not only think about what we can do with a material that has already grown. And all of that discussion is situated somewhere between us as humans, nature that creates the material, and the tool that we use to bridge the gap between us and nature. But integrating the growth process of trees into architecture is not a new idea. Absolutely not. We've seen some of these pictures yesterday during the presentation. You can see on that slide multiple examples of what we've, during research, qualified as Baubotanic, which is buildings plus botanic. And I'm not going to comment on that much. It has already been discussed. But the important thing is that it absolutely works, but it does have some challenges, such as the time that it takes to create such architecture. And also, as the name suggests, in Baubotanic, we put the Bau building first, and then we shape the trees to fit that building. But what if we flip the script and put the botanic first and the Bau second? And what if we adapted our architecture to what nature has already created, because nature knows what it's doing and is probably doing a better job than us sometimes, which is also not a revolutionary idea in itself. That also has been done before. You can see on the slide some examples of structures made from wooden pre-arched. So the trees were grown arched, and then pairs of trees were selected and then put into buildings as arches that fit, or from manuals of constructing wooden ships that you have to choose specific tree forks that fit certain types of an element of a ship. The challenge of that, however, is integrating such a complex natural material into a design process. And the material is ever changing, so we think that the design process has to be flexible, It has to also somehow be ever-changing, and we believe that all that, maybe not all of that, but a lot of that can be achieved using computational design tools, as stated in the title, since they allow us to make the process more flexible. So, as part of an ongoing research, we've devised a simplified algorithm for creating timber architecture and tested selected parts of it on a plot near Warsaw. And the BER algorithm consists of 5 steps, from identifying what resources we have, preferably locally, qualifying them, simulating some material division in order to make it into architecture, and then finally designing and constructing architecture. And then below we have listed some computational or just newer tools that we can use to aid us in all of these steps. It is worth noting here that this is not a one-way process, despite what the diagram might tell you, but we think that for the process to happen well, we need to go back on the steps and inform the previous steps with the later steps, and then go back again, and then keep learning. And then some examples. One early stage of research on the synergy of humans and nature is the first 2 steps of these, so qualifying what resources we have locally. So in the fragments of tables you see on the slide, we've compiled 3 species growing in Poland, and then found out their quality and geometry characteristics, then compared that with certain building elements, and also what qualities they need. So for example, if we're talking about a roof, it would be nice if the wood covering was more resistant to water. If we're talking about interior details, that's not as important. And then we've compiled those 2 to see if we can draw some conclusions as to what type of tree might be most relevant to what type of building element. Coming back to that slide for a second, and then also another example of applying the first 4 steps into part of an architecture project. That was a test application, and that slide is a bit convoluted, but let me explain. So for the plot we've analyzed, which was located near Warsaw in Wola Karczewska and also has an existing sawmill, we've calculated that yearly we could harvest a certain amount of material without depleting completely the resources that we have on site, which was not much because it was around 22, 23 trees of around 18 to 20 meters tall, and they were all pine. So you can see that this is not a lot of wood, and if we want to create a building out of that wood, preferably out of what we have on site already, we need to use it well, and we need to use it very responsibly. So then a series of optimization algorithms was created, first to analyze the wood and then to divide it into standard planks as much as possible and then see what remains. So of the white drawing that you can see in the background, this is what we got when dividing the material. What is important is that less than 40% of that is normal sizes. So probably the right 1/3 or is normal 12 by 12 planks, and the rest is irregular material. And that's also a case for computational design tools to be able to adapt to a different geometry, to a geometry where there's thousands of elements and each of them is different. And so those elements were again during an iterative process combined into multi-layer trusses that again were all different, but they were all devised in the same logic. Yeah, we don't have that much time. So to sum up quickly, the research is still in progress, but the three main conclusions we have is that, first of all, wood, as every natural material, we should consider the entire process of its creation and not only the process that we as humans take part in. Secondly, that the tools are evolving and we as architects should evolve with them because we're going to be left behind if we don't. And then thirdly, that maybe architecture should consider adapting to nature and not adapt nature to itself. Thank you.
Thank you so much for the last presentation in this session. I love the last conclusion that we shouldn't adapt nature to us. We have to do this reverse. So thank you so much for attention, for being here with us. Now we have a short break, coffee break, 15 minutes, I think, and let's meet again. Hello. Dear guests, can we continue? Do we have Anna Serbyn already? Yes, okay. A presentation, okay. Okay, a gdzie kogo się zmienia? A, czy możemy zmienić kolejność, ponieważ pani musi się wyprowadzić z hotelu, ale to nieważne. Pani Anna Serbyn będzie pierwsza, okej?
Była trzecia, tak?
Czwarta. Była ostatnia, czyli ostatnią prezentację. Dobrze. Let's begin then. We start the session 8. A few changes in our program. The first will be Anna Serbyn from Lviv Polytechnic National University from Ukraine, with the presentation, the use of modern materials in reconstruction projects in the historic complex of the Potocki Palace. But I see that there are small changes in the title. Yes, so please do the update. The floor is yours.
Yes. Good day to everybody. Thank you for having me today. I'm very excited to join the conference. And today I want to present our research on the sustainable materials for the future in the context of heritage preservation, and particularly in the revitalization project of the Potocki Palace in Ivano-Frankivsk. So when we are discussing the choice of the materials for the historical environment, it is very crucial to consider the options very carefully, because these materials should ensure the dialogue between the history and the present and the future. So I think we need to get a little bit of context of this historical environment. It was established in 17th century when the city fortifications expanded and this area of the palace was added. And the function of Potocki family residence only lasts for 100 years. Then the military hospital was for 200 years. Then it was a period of abandonment in private property for 14 years, and from 218 it became a municipal property. So we have a lot of identities. We made this identity profile of the complex to know the values that we want to present, the values from the palace period, urban structure, a lot of buildings, and the values from the hospital period, and of course modern values that we also want to present in the revitalization of this place. And the presentations of the archaeology, now we are only starting the archaeological research, and the presentation of archaeology in this complex is a tool to show the identity of this place. And there is also one more role of the archaeological heritage. It gives us a unique insights to the human development. And also, it has a great role on educating and communicating about the sustainable development as well, about the sustainability, because usually the best solutions for the nature lies in rethinking the past techniques. and the past materials. And we had recently the competition, the architectural competition. In fact, the Faculty of Architecture was taking part in it, which we are really grateful. This competition focused on finding the conceptual solutions for the reinterpretation of the Potocki Palace complex, and as well to explore modern technical solutions and materials. And I want to share some concepts regarding archaeology presentation from this competition. So the first project from United Kingdom, this project has a great philosophy. It considers the continuous excavation of this place, and these excavations are like frozen in time operation. And in this project, they want to celebrate the beauty of excavated earth and the constructions they made from rammed earth. In fact, they use also the recycled brick, but I will talk more about the rammed earth today. And we think it's a great idea to use, to show this atmosphere of archaeological research in usage them such material as rammed earth. And we made some investigations about the usage of this material in archaeological shelters, and in fact, it wasn't used in archaeological shelters. Only one example, it's the reconstruction of the recreation of the volume of the Crafts House in Xanten in Germany. These blocks from rammed earth, but they recreated the technique from the Roman craftsman houses. And another example that is related to this technique is that extends the idea of using earth as a material is the use of soil profiles, the stratigraphy from its example from Poznań, Genius Loci Archaeological Reserve. So they take by parts this ground from directly from archaeological trenches. They put some on some fabric on the glue, and they present it within the archaeological reserve itself. So another example from the competition. A very interesting concept on presenting the archaeological structures, but still preserve the biodiversity, still preserve the greenery of this park central space by adding the third dimension to the urban structure. This allows us to preserve this historical structure, but also to present the archaeological finds that lie within this structure. And the other, we are trying to investigate the examples from another branches of architecture, and we try to use low energy and natural local materials. And this is a great example for usage of this biomimicry. So it's a matter of sensitive architecture. This research from Stuttgart University, they research the natural conditions of some kind of wood material, and when the relative humidity is high, the wood started to make a curve, similar to the pine cone. They made all this research, and the research was very interesting because due to different geometry of these pieces of wood, it curved differently, and due to different geometry of these holes, we can do direct calibration and inverted calibration. So when the relative humidity of the open air, it can be opened due to ventilate the pavilion, and when the And when we also can do the inverted calibration. And so these are two pavilions, Hydroscope and Hydroskin, from Paris. It's a great way to imply this technique to archaeological shelters as well, because it's low energy construction, local material, weather responsible systems that requires no electricity. And it's very crucial because sometimes these archaeological finds are in the places with no electricity, not in urban spaces, and we need to present them as well. So another challenge for presentation of the relicts of architecture was the wide use of transparent structures, especially different kind of glasses on the frames. And that structures in the long run, they appeared not to be so good because they created the greenhouse effect, the direct sunlight were causing negative influence, and they were demanding a lot of electricity to keep the climate inside this reserve. And so another great solution actually from 1986, a shelter for Roman ruins in Chur, Switzerland. So it's timber construction with a skin of wooden lamelles. And these wooden lamelles, they, in night period, they make this transparent effect, and they ventilate very good. This here, when on this right scheme, you can see the ventilation of this protection structure, and also it defends from the direct sunlight and demands a very low electricity consumption as well. And so this shows us that we have to take the inspiration from the traditional local techniques, from the traditional materials, and actually like some philosophy that we developed during this research is that actually we can consider these archaeological remains itself as the most valuable non-renewable source of the material from the past for the future, because it teaches us itself the sustainable way of building, living, and to finally stop competing with nature and to live in harmony with it. Thank you.
Thank you so much. I have the pleasure on the behalf of Professor Anna Wierzbicka to invite you, our guest, to the opening of the competition that took place recently, Reinterpreting the Space, and it will take place at the Faculty of Architecture, main courtyard, as far as I know, tomorrow at 10. So please come. And the next presentation will be decarbonization of construction processes, introducing zero carbon natural materials, including wood, into circular construction. And this theme will present Jan Dowgiało and Anna Zawadzka-Sobieraj from the Polish Association of Natural Construction, Mech Built Ecological Architecture Studio, Warsaw, Poland.
Hello. The title of my and Jan presentation is also the title and the subject of the grant for the development of natural building in Poland, which we recently finished working on. And later in this presentation, I'm going to say more about it. Okay. Just a few words about me and Jan, my business partner. We founded and run the Mech-Build Ecological Architecture Studio, and we are designers of ecological buildings made of natural materials, as well as we work on urban projects based on public participation, and we do small and large spatial form interventions. I'm also the specialist for the introduction of European Union criteria for environmentally sustainable activities related to taxonomy in development investments. We are members of Polish Association for Natural Buildings, and we founded this organization in 2012, and we are a group of architects, designers, people who build the houses and sell the natural products, and also there is some group of enthusiasts who work with us. And our main goals are promote and develop natural buildings techniques. We organize workshops, training courses. Each 2 years we organize natural festivals, and we also develop cooperation and knowledge exchange between the members. We perform tests and researches about natural buildings materials. As an association, we implemented the mentioned grant. Okay, the carbonization, I think there is no need here to explain about the carbonization, but just I want to zoom in the carbonization strategies, and among them, the most important for me, this one which is using renewable, ethically produced, low-carbon building materials of plant origin. I think it was already said a lot about this kind of materials, like earth materials, wood, agricultural and forestry waste, like a straw. Natural construction is not a new discovery, because it's based on traditionally used materials, locally sourced from the surrounding environment. And for this reason, some people may think that it's like kind of ancient architecture, open-air museums, and that we are using manual construction of buildings, which is not inadequate for the present day. But it's not like this. We work on contemporary aesthetic projects, and we used modern technology to rise buildings. The study verified that the use of technologies based on natural materials as a tool for decarbonization of the construction industry. Natural building solutions reduce emission in the production of materials, the organization of the construction process, operational footprint of the building, and the disposal of the wastes. So far, efforts to reduce the emissions in the buildings sector focused on reducing this operational carbon footprint. But there is not as much done in terms of footprint of materials, of producing the materials. Here is the material pyramid, and you can see that all the natural materials, we have it down here with minus footprint or very, very small carbon footprint. And of course, natural buildings technique fit into the principle of cradle-to-cradle economy, as biodegradable materials circulate in a closed biological cycle. Also, the demolition waste from buildings made of natural materials can be easily managed and can be reused even within the same project. And the grant, we received funding of almost 800,000 euro from Iceland, Liechtenstein, and Norway funds. The leader of the project was the Institute for Environmental Protection, National Research Institute, and we, as our association, we were the partner of this grant. We finished the work this year, like 1 month ago. And I will, first maybe I will tell about the reasons. We tried with, first with funds from the grant, from the funds of LIFE project, and we think that what we can offer as in terms of natural materials, it's like this way of the transformation where we are right now. So in Poland, for example, the first design for a multifamily building are based on the criteria of the European Union economy or do not significant harm principles. And those projects are currently being prepared. And for example, one of these rules is about emission of toxic substances. And of course, natural materials, they have no toxic substances. In Poland, also, it was the reason to write this grant. Natural materials are used almost only in single-family houses. There is a lack of knowledge, lack of legislation, lack of good practices, and we decided to try with this money to support natural construction and, of course, the circular economy in Poland. And among the things which we have done using this funds, we did substantive studies, the roadmap, the LCA calculation methodology for natural materials. We wrote set of recommendations, different one, like for different stakeholders. We did laboratory tests. We prepared, mainly me and Jan, investors guide. Later Jan will say about it. And there are also educational effects like webinar, practice training, preparation of Polish DUS, so additional professional skills programs for vocational schools. We also prepared curriculum for universities. And we did some information campaign like multimedia exhibition, series of articles, and I have some also information about detailed information about the impact. It was 18,000 people saw the exhibition and workshop at construction first. 800,000 electronic media reach we had. We had more than 250 webinar participants, nearly 400 workshop participants. And we reached the individual investor, commercial one, and we are trying to reach this way local governments also. So, short impression about the results. Everything is in Polish, But for example, that's the roadmap. And here we developed the natural technology charters, how to build using straw bale, prefab, hemp, clay, earth, and all type of products made from them, with assessment for closed loop economy too. Here is the example for the compressed straw. Then we do partition studies. We developed some proposals for partition using natural solutions, also with some detail and with some thermal humidity calculations. We did LCA analysis and calculations models, and for raw materials and natural materials, timber and plant raw materials are examples of biogenic building materials that can store carbon dioxide for long periods of time. So methodology should be developed to account for the carbon storage potential of building products. And we also did fire test. Here we have results from for straw and hempcrete. And the result obtained by hempcrete opens up a wide range of possibilities. The next thing was curriculum for universities. We wrote, we prepared many presentations, many information which can be used by universities for the students to learn about straw, about all types of natural materials, constructions, prefabrication, and all the possibilities. That's just one page from thousands page, I think. And the last thing is the investor's guide, and I will ask my partner to say a few words about it.
Okay, hello. So the investor's guide is the last part of this grant. It's an online presentation. It was supposed to be 50 pages. At first, it blew up into 300 pages. It's this kind of box full of information about natural building. A lot of this stuff was said today during different presentations. But the reason for this is just to kind of make like a manual for investors, for private investors, home owners and homemakers and developers to use and to implement natural material solutions and technologies instead of what is traditionally used, which is, as we know, is not good. We think that we believe that even small changes like plastering your home, your apartment with natural plasters or clay, or painting it in clay, or using natural wood instead of some plastics and unnatural materials. It's a really huge change in from the point of view of health and the climate. So we want to this whole manual is about this, to prepare people to show them that there is a choice, even in tiny small things which are important. One of the chapters is about thermal insulating existing buildings using mostly straw and hempcrete, which are really good because the buildings breathe, unlike with styrofoam or like the mainly used materials now. The manual contains a lot of lots of simple details and well, okay, it's like there's a lot of information, but it's still just this tiny bit. It's we just want to show the most basic, simple stuff, and that's what we did. So it shows ways to insulate a building by yourself, with your friends, a lot of DIY solutions, simple stuff with natural and local materials. There is also a part with projects. They are like modeled exemplary projects of single-family homes. There's a row house made of hempcrete, and also apartment buildings. So it's larger things for developers. The main goal is to promote, of course, natural materials, but in every one of these projects we try to kind of, okay, forgot the word, but to przemycić. Jak jest przemycić? What? To smuggle, thank you. We tried to smuggle some really also simple solutions like passive solar heating and ventilation, water retention, which are obvious for us as architects. We use them all the time, but for investors, they are like completely unknown things which can save them money and help all of us. And okay, this part also contains details, more or less simple details which can be done by the residents themselves. In some cases, and some not. It's supposed to show the range. And the last part was done by Przemek in Przemek. So he showed some of these examples today of good practices, of examples from mostly from Europe, I think, right? From Western Europe, but things which we can do but are not doing here in Poland. So it's just to show that it's possible. And well, that's it. This whole thing can be downloaded from dekarbonizacja edu.pl. And OSBN, that's the Polish Natural Builders Association. MacBuild, that's us. We'll also throw it in there someday when we have time. And for now, thank you.
Thank you very much. Please welcome Anna Tofiluk from Warsaw University of Technology with the presentation, Activities of the Sustainable Architecture Division of Association of Polish Architects, Warsaw Branch, with particular emphasis on the environmental assessments of buildings.
Sorry, this title was a little bit too long. Yes, I represent Warsaw University of Technology, Faculty of Architecture, but today I represent even more than our university. I represent Association of Polish Architects because our association is also a partner of this conference, and I was invited here as a member of association, and not only as association as such, but also I'm the member of Koła Architektury Zrównoważonej. We can translate it into Sustainable Architecture Group Division, I don't know. Abbreviation is CAS. And this is the group of architects within the Association of Polish Architects. Here you have people who presented, yes, already all of them. Kinga didn't present yet, but other people have already presented during this conference. They are all our members. Kinga, Anya, and Jan also were the they created, they established our division, our group within the Association of Polish Architects in February 2018. And of course, it wasn't the first time when architects in Poland started to think and to talk about sustainable architecture, but I think it was this 6 years ago, the discussion which we are having right now wasn't so strong and wasn't so common. And I want to think that partly we started this discussion. Generally, in our group, there are very different architects, let's say. There are people, for example, like Ania and Jan, who are focused on natural materials, low-carbon materials. You already know, yes, but there are also architects who focus on buildings of steel, reinforced concrete and glass, but which have certifications of BREEAM and LEED. And they are also landscape architects like Kinga. So we are a group of very, very different people and very different architects with different approaches. But what we want to do is to discuss how to do it better. Yes, how to make our architecture better, more sustainable, more climate responsible, and we want to discuss which way is the best. Not always we agree in everything, but we discuss. And as a result of this discussion, or something that is related with this discussion, are a lot of events which we organize, or we are co-organizers, or we are just invited to take part, just for example, like today. So I will go very quickly through workshops, conferences, lectures, and seminars, and other events which we have which we have organized, which were tailored mostly for architects, but not only, also for just people who are interested in the subject. In many different places, also in cooperation with Faculty of Architecture, and that was not a very nice time of pandemic, so we couldn't have organized anything in real environment, but just we moved in cooperation with Zodiac Warsaw Architectural Pavilion. We organized more than 7, I don't remember, 8 or 9 meetings, events about different topics related to sustainable architecture, like renewable sources, natural materials, timber structures, and others. And the good thing about this not very good time is that it's still available and you can still listen and watch if you want. Yes, as said, we cooperate with Warsaw University of Technology, Faculty of Architecture, also because we have people in our division, yes, also from the faculty, and we helped to organize the first Redefining Warsaw, Redefining Cities in the View of Climatic Changes conference. What you can see here, there are workshops before the conference. Those are the pictures from the conference, and also the second one, which was in 2023. Also, Faculty of Architecture organized the competition for the best final projects for students from all over Poland, not only from our faculty, and we have our people, let's say, in jury. Not only those ones which work at the faculty, but also other architects from our association. This was, I think, important in the short history of our group. In 2019, we wrote a declaration, Architects for Climate. Maybe there is no time, yes, to talk about each part of this declaration. There were the principles of our ideas, how to do it better, how to think about architecture and the future. And just we are aware that we need to do something in a little bit different way that we used to do. Now it seems that it's quite common already, but really in 2019, it wasn't in Poland, especially among architects, so common thing to discuss. So we wanted to start this discussion among architects and just ask our colleagues to read the declaration, and if they agree, to take a picture and show in social media that they agree with our ideas. Also the important thing, which maybe I will say a little bit more about, is sustainable built environment criteria evaluating system developed for architectural award of the Mayor of Warsaw, which we developed in 2020. There is a group of people who were involved from our association, and these criteria were developed according or based on the agreement between the Warsaw City Hall and the Warsaw branch of the Association of Polish Architects. Yes, I will go through it very quickly. I will explain the story behind. One of the reasons we did it, not only, as I will tell you in a moment, was that we wanted just to explain what we really think about sustainable architecture, that we know that this is a very complex issue. Here we are talking about materials today and yesterday, and it's of course a very important part, but only a part of really a bigger whole. And this is the matter of all our architectural and urban scales of design, from urban and planning scale, yes, for land development, or even where we choose the location, to the very detailed solution and materials. And this we developed after, yes, a long discussion within our circle, within our group. And this is somehow maybe not a manifesto, but we just wanted to put all important criteria which are related to sustainable architecture in this, and we hope that it would also have an educational role. And I will go through it very quickly, but if you want to know it better, this is quite easy to find in internet. The story behind is that every year in Warsaw, the Mayor of Warsaw, yes, give his award for architectural objects. And during the 6th edition, the jury, or just the decision makers in the City Hall, between the jury, started the discussion, wanted to add to the group of awards, because there are 6 basic categories, and there was one special category for accessibility solutions, especially for people with reduced mobility or perception. And at that edition, decision makers decided that that's a time to have a new special award for ecological solutions. And the first time they wanted to give this special award, they realized that the problem they had. This is a short list of the finalists, because the special awards are chosen from the short list. And if you take a look, you will see very different buildings, and not even buildings like a graduation tower or the Warsaw Bench, so very different objects. And how to compare them and how to decide which one is the most ecological one. So they finally decided that the most ecological one was the graduation tower, but they realized they need criteria. They have, maybe not a similar, but also they have a criteria for this other special award for accessibility, so they decided they need criteria to choose this kind of award. And they asked us, yes, to prepare this kind of document. We based our work on the analysis of existing green and sustainable standards like a BREEAM, LEED, and others. We, of course, analyzed a lot of sources, books, and also municipal documents and regulations, because, of course, we had to go along with them. Of course, we knew that this kind of the criteria, this kind of evaluation system must be different than the criteria like for a BREEAM or LEED, because it must be fast, because nobody takes a lot of time for this kind of choosing, yes, but it must be quite cheap also. So we were limited with the budget for our work, but also we knew that the whole system of choosing is also limited with the budget. But at the same time, we wanted, yes, to go through different aspects from, let's say, scale 1 to 500 to 1 to 5, from social issues to energy efficiency. Just generally, we wanted those criteria to be multi-criteria, and just the evaluation is multi-criteria evaluation. We were thinking how to compare objects and buildings which are completely different, yes, that they are buildings and objects which are constructed with steel, reinforced concrete glass, but also houses of clay and straw, yes, like those ones which were presented before my presentation. So how to compare things which at the first glance seems to be not possible to be compared. Maybe this is the list of parts of the whole document. Maybe I will go further. Important thing that there is a description, of course. There is the manual how to conduct such a evaluation, because we prepared this system believing that maybe somebody else would use it. Yes. Finally, which I will tell you at the end, every year we are asked to prepare such an evaluation, but we prepared it in a way that it could be used by, no, maybe not by everyone, yes, but any other architect who is more or less aware of sustainability. There is, of course, the glossary of terms. Instead, there is a kind of the checklist, so the evaluation sheet. Then there is a summary table of the evaluation, documents used to develop the criteria, and very important, kind of the appendix with the information which are needed from architects. And generally, the idea is that if the object is on the short list, architects are asked if they want to be considered for this special ecological awards. They are asked for a little extra information about the building. Key issues, of course, in those criteria are carbon footprint, energy efficiency, circular economy, water management, heat island, biodiversity, inclusiveness, and health and well-being. And we have 6 basic criteria. I will go further, yes, showing only the main aspects which we ask for in each criteria. So the first is the plot development. We asked about the history of the plot, environmental context, biodiversity, the trees, water retention, fencing, green roofs, green walls, light pollutions. And the last, this is maybe important, the 11th point here is other solutions, because we also knew it was, yes, 4 years ago, And this last is very useful right now because we knew that the whole the discussion about sustainability is quite new. And we knew that we can't predict solutions which could come next, yes? So this other, the last sub-criteria in each large criteria is related to the solutions which we didn't predict, but they can be added here if they are sustainable. The second is mobility. So this is related to location in the city and with all the things which are related how we move. Sustainable use of the building, then the most architectural part, let's say, so design solutions, constructions, materials, details. So here we look into the project really and in details. Then energy efficiency and installations. This part was prepared by our colleague who is a specialist engineer for installations. And the last one, health and comfort. And this is the appendix with questions for architects. That's how the evaluation sheet looks like, but I really believe people can use it just as a checklist. If, I mean, architects want to know if they really, the way they think about sustainable design is the good way, they can go through this and treat it as a checklist and see what should be done. And the final two sheets with the points. And I'm not going to tell you about the system of points, but this is very smart. And this led to compare those things which at the first glance are very difficult to compare. And the final result is in percents, not in points. Yes, the first time, so the year after, we had the first chance to use this evaluation system for the award, because as said, we were asked to prepare the evaluation. And every year, since that time, we make an evaluation. Finally, we have 1 or 2 best objects. And we give a recommendation to the jury. Very often, we also have our one person in jury from our group who represents us. And the jury, finally, yes, we don't choose the object which will be awarded, but we just give recommendations. And the first time it was the Eco Park in Ursus. This is always like this, that every park is better than the building, yes, when we think about sustainability. So yes, here at that time we recommended a park and also a building, which in our score was a little bit worse, but it was a building and we as architects wanted to recommend a building, but finally jury decided for this one. Then there was a school, primary school in Wilanów. The next year, also kind of the park, so the modernization of Romantic Beach in Wawar. This is the part of the Warsaw. A year ago, school for children from Ukraine in former office building. This is a very, very, very sad story, but also very interesting because this is the example that the reuse of the building. So the building, which was in the first place an office building, can be used in completely different way. Yes, that we can redefine the building and the function. And also a lot of elements which are here, which are used in all these interiors were designed, and a lot of elements also, this is the reused elements, but really the result is very, very interesting and very beautiful. And this year, yesterday, yes, I asked you to, and also today, Arthur asked you to, or wanted to tell you that this is a nice place to visit. Yes, also because it got our special award, but it also got all the awards possible in Warsaw, as said before. What is for us very important? Because that was, as said, kind of the beginning of the discussion. This is, of course, a longer story. And not only people from our association or from our division are involved in this story. Also, a lot of engineers, decision makers from the city hall, and not only. But with our criteria, the discussion was started about green building standard for Warsaw. So the city hall. The people within City Hall wanted to create a standard for the buildings which are paid, which are constructed for the public money. That those buildings should be more sustainable. Yes, I'm saying sustainable as a word which contains everything what important, although I know it's also could be a discussion what it means. So generally, yes, there was a discussion in the City Hall with us and other people who are interested in the subject that the City Hall want to create a standard for the buildings they build as schools, theaters, other public buildings, also housing, just for the public money. And this discussion was started with our criteria, and we are just we are just waiting for the final decision of Mayor of Warsaw, because those Warsaw Green Building Standard is just waiting to be accepted, this final version, and we hope, and we also, the same group of people from our club, we were involved, but not only us, of course, but we were involved in developing this Warsaw Green Building Standard. Yes, I'm about to finish. I want to invite you for our meetings. If you an architect and want to do something with us, please, you can find us in social media, of course. You can email us. We are a very nice group of people. As you can see, this is only a short part. Yes, so I hope see you in Association of Polish Architects. Thank you.
Thank you so much, and congratulations. A great energy I can feel. Okay, we will join you immediately. Now I want to welcome Halina Koznarska from Lviv Polytechnic National University, Kinga Zinowiec-Cieplik from the Faculty of Architecture, Warsaw University of Technology, and Leszek Wiśniewski, also from Warsaw University of Technology. And the topic is Modern Solar Energy Systems, Influence on Urban Landscape Aesthetic Qualities.
Hey, good afternoon. It's a pleasure to be here and to be able to speak in front of you about the subject that I think it's somehow very important right now, because the words climate crisis were probably mentioned a few times, or more than a few times this conference, but I think it's worth also to discuss not only technologies that we use to deal with that, but also how they change the landscape that's around us. So this presentation was prepared, as mentioned, by Mrs. Halina Koznarska from Lviv Polytechnica, and in my cooperation, and Kinga Zinowiec-Cieplik. So first, renewable energy sources. There is a list of them. There are different types of them, and we are now trying to use them to replace the fossil fuel energy that is causing climate change. And what I think is worth to mention is that Europe is quite successful in that. Like last month, just about 20% of the electricity in European Union was produced using fossil fuels. So the rest is renewable energy and nuclear power. Still, European Union has a goal to reach climate neutrality in 2050. But after Russia's full-scale invasion on Ukraine, it decided that it has to make that transition faster. So the program Repower EU was prepared, and it foresees, for example, so-called European Solar Roof Initiative, which means that there's going to be an obligation to use solar power in new first public and commercial and later also residential buildings. Solar power already is quite important in European energy mix. So this is once again last month data. It was almost the same as the combined coal and gas, so we are already quite successful. I just want to remember. I just want you to remember this wave. Because it's going to be important later. I will discuss why this changing of the solar power during the year, during the certain months. Solar power is not only about becoming more climate friendly. It's not only about more energy independence, what is the reason for this Repower EU program, but it could also be the reason for going into solar is for economical reasons, just to make electricity cheaper, especially those who use directly solar energy in their homes, in the places they work and so on, could definitely reduce the bills. But there are certain challenges related to using solar energy. For example, most of the current solar installation, they are just added to existing structures. And first of all, we have the problem, structural problem, that the structures may be not prepared for that, and solar installation, they have their own weight, but at the same time they also could create wind load. So there is this problem that they may damage the structures that they are put on. But at the same time, it is also very important, and for me as an architect even more important, that they are changing the appearance of landscape of the city because they are added to something that already exists, and they are so different that this change is it's really remarkable. And quite often, I would say, not very positive. But there are solutions to that. We can think about integration of solar energy into the building. For example, we can use the solar elements instead of roof, not just putting them on the roof. And it's the best to think about it just at the beginning when we design the house, or maybe when we retrofit it. Then those results are the best. These solutions for the integration, they are called building integrated photovoltaics, and there are quite a lot of them. Quite famous is the system introduced by Tesla, which just produced the solar tiles that could be used instead of the roofing materials. There are different companies that produce it. So, for example, this is example from Polish company ML System that is also producing solar tiles. It will be used soon in the renovation of New Vichnich Castle, so we will see how this type of technology could be fitted into historic building. But at the same time, there are problems related to the fact that companies that offer these solutions, they do not always offer other elements of the roof, so then there may be a challenge of integrating elements from the traditional roofing companies and these new solar companies. Also, solar panel is basically the solar cells, and they are covered by glass, and therefore usually even those integrated solar panels, they have a different appearance because they shimmer. So they have even if they have the same color, that appearance is a bit different. So it's still better than just to have an attached solar panel on the roof. But we have to think how to maybe integrate it better. And the problem is that matching the colors, the size, and so on, it's still a problem. Of course, it's worth to think where we need that solutions. Here is an example of evaluation methodology created by École Polytechnique de Lausanne. And it includes two important factors. So one is visibility. So basically, we should think how visible are the places that we use solar elements, and also the sensitivity, which means how important that appearance is. So definitely it's going to be more important in this historical environments and less in industrial parks or shopping malls. So based on that, we can think whether we can use this mass-produced solar power, or maybe with this building integrated photovoltaic solutions has to be used. It's also worth to mention that roof is not the only element of the building that solar power could be integrated into. It's worth to think about integrating into the facades. One of the reasons is that, for example, during the winter, the vertical surface, they provide more energy than during the summer. So here is a chart for Lviv, how much energy could be produced depending whether it's winter months or summer months, and the orientation of the solar panels. The reason is just the sun rays are on a different angle in different seasons. It's also worth to think about how this production goes during the day. Here's an example from Switzerland. We can see that if we feed the facade with east and west facing solar panels, it provides this energy in different hours than the south facing one. And that could be a solution for a quite important problem for those who live in Poland. Maybe you have heard in May that we have to switch a lot of solar power because the grid cannot handle it. And at the same time, we have a problem in the evening that we need to use fossil fuels because we don't have that energy. So just changing the orientation of solar power could somehow solve this problem. Of course, not fully. Sometimes we just need storage. When we talk about facades, of course, we also have to think about aesthetics, maybe even more than when we talk about the roof system. But at the same time, solar power could be an opportunity to create interesting architecture, like here in Zurich, or here in Copenhagen, that are the cladding that is made of solar panels. We can also use them as a shading material. So here there are the bristlets made of solar panels in Germany, in Freiburg, and here in London. But also we can use them, for example, as railings. This is also, I showed that we have the solar cells that are covered by the glass. They could be covered by the glass from both sides, and then we have that effect. And individual cells can have different shapes. So this really could have an aesthetic effect. Here, the wall that is filtering the sun, or the roof, this is Central Station in Rotterdam, so they also could prevent this overheating or just create more shade in the interior. So summing up, it's important to introduce solar energy into our environment, but in a way that it will not destroy its aesthetic value. I would like to stress what's on the lower parts, the legal framework, because it's worth to remember that, of course, BIPV, they may look better, but we have to remember that there are certain constraints related to its effectiveness, productivity, and also costs. So the investors usually will choose the cheapest solution. Those more aesthetic ones are more expensive. And because of that, we have to create a legal framework that requires to use maybe this more expensive, maybe less effective, but those that create a better landscape. So in Poland, we have the constraints related how the law is shaped. So it's also up to us to put that in the discussion that it has to change in order to create not only ecological, but also an aesthetic future city. So thank you very much.
Thank you very much for this interesting insight. And the last presentation in this session, Mirosław Siennicki, Violeta Barcewicz, przepraszam, sorry, i Stanisław Wierzbicki, Warsaw University of Technology, Faculty of Civil Engineering, Poland. And the title will be Structural Steel as the Building Material for a Responsible, Sustainable Future.
Thank you very much. Good afternoon, ladies and gentlemen. I have a pleasure to represent our team from Faculty of Civil Engineering. My name is Violeta Barcewicz. I am Associate Professor at the Faculty of Civil Engineering, Warsaw University of Technology. And as we are, of course, sure that we are, as a civil engineers, as a structural engineers in minority, however, I think that we have some common issues with architects, so for example building materials which are sustainable. So I will try to encourage you, you as architects, to use more steel, because you will see during this presentation that there is material which is worth for consideration. During this conference, many times we heard the terms which define the current global challenges in architecture and civil engineering, like sustainability, circular economy, decarbonization. If we talk about circular economy, of course, there is the main idea is to ensuring resources remain in use as long as possible, to take into account such activities like recovering, reusing, remanufacturing, and recycling of such resources, to be able to create new products, of course, and you can see here the example of circular economy, and on the basis of steel, which is the fundamental material to circular economy, because from ages it is known that steel can be, of course, easily recover from the old scrap, yes, to new materials, and can be, of course, rebuilt in different, let's say, building products, buildings generally. So this is, I could say, nothing new, but of course there are some other developing ideas how to make steel even more sustainable than, for example, usually well-known circular economy approach. What I can say, what kind of strategies can be proposed, or what architects as well as engineers, of course, can take into account, is, of course, recycling and reusing steel, optimizing structural designs to minimize material usage, because this is the idea of, let's say, decreasing the footprint, CO2 emissions. Currently, there is very easy to optimize the structures, having a computer-aided design. So this is also one of the tasks. When minimizing material, building material, we can save more ecological solutions. And of course, adopting energy-efficient construction methods, manufacturing new products from scrap, quick assembly of steel structures, which is the benefit which we can, of course, measure. The time is money, as we can say, but also, this quicker assembly, quicker erection
quicker construction of steel structures means less waste, less, let's say, the amount of waste on site. Moreover, we can say, taking into account the benefits of steel, structural steel, we can say that there is one of the most, let's say, strength material among other structural materials. So it's relatively low self-weight, comparing to very high resistance, very high strength. Currently, there are solutions with very, very high strength materials. Such products are developed, such steel grades are developed that there is no other materials with such mechanical properties. But this self-weight, which is very low, comparing to high strength, also can be taken into account in the savings of CO2 emissions because of the less amount of transport deliveries, for example, to sites. So we can save some costs from the transportation, and of course we save let's say the pollutions, the CO2 emissions generated by transport. So now I will focus on the main issues which I mentioned before. So, for example, in case of recycling, so steel is the material which can be recycled many, many times. There is no limit for this purpose. So infinite recycling without loss of properties, this is important to mention because other materials which also aspire for being considered as sustainable materials can be properly, selected, properly constructed. In case of steel, there is exactly the same or even better properties if we want to add some alloying elements or something like that. So there is permanent material. It's easy when we talk about separation and recovery because of magnetic properties. So there are such steel attributes, but direct benefits from steel recycling is, for example, that we can conserve raw materials like iron ore, coal, and limestone. And of course, we save energy, as well as, of course, the possibility to give job places regarding this branch of industry. If we talk about reuse, another topic which is also very important, you of course know that the steel structures is generally assembled on site very quickly because of connections, demountable connections, mostly using bolted connections. So as far as that can be quick erected, it also can be quickly dismantled. And you can see that can be this idea of, let's say, modular building or temporary building or semi-permanent building to be able to quickly erect and quickly disassemble. But there is also another idea, very modern, very trendy, let's say, to reuse the structural elements from another building, which, for example, ends its life, and use the demolished materials, demolished steel elements to another, totally different, or similar or totally different buildings. This idea is very much promoted in Europe. I'm a participant and also the member of European Convention of Constructional Steelwork, and each, let's say, not each year, but each, let's say, 2 years, there is a competition of European Steel Design Award, and last year, the laureate was the building which was constructed in such way. So it is constructed from 165,000 kilograms of reused structural steel, which was taken from, let's say, after 50 years after 50 years of life cycle of the building, which was in the vicinity. That was a Leiden University Laboratory building in the Netherlands. So from this, let's say, demolished materials, that was made very quickly, very nice, the new building, which was, of course, the laureate of the European Steel Design Award. And the last, let's say, idea which can be, for example, very sustainable currently is the idea of green steel. This idea based on alternative steel-making processes, because normally very traditional way is, let's say, blast furnace, the source materials like iron ore, coking coal, limestone, and so on. Very high amount of energy. And after blast furnace process, there is also oxygen converter and something like that. Alternative way is to use electric arc furnace to, let's say, to produce the steel from scrap. It can be used, the scrap with source materials, or like it was given in the, let's say, new program led by ArcelorMittal Europe, XCarb, to produce the steel which is almost zero carbon emissions. So that's why you can see here on this example that there is a steel making process based fully on scrap, so recycled steel, and 100% of green electricity. So no additional energy taken from, let's say, standard options. So take into account electric arc furnace steel making process. Then finally we have green steel, which results in very low amount of CO2 emission, which is approximately 0.3 per ton of finished steel, which we can compare with the amount of CO2 emission based on the, let's say, traditional process, which is equal to 2.3 per ton of steel products. I can also even mention something in the between, which is also sustainable and can decrease about half the amount of CO2 emissions comparing to the typical traditional process, when, for example, we also can use electric arc furnace, but we can replace, for example, carbon by hydrogen. Such steel-making processes are available, for example, in Spain, also that was developed by ArcelorMittal, and also the carbonization is efficiently measured and efficiently, sustainable steel is efficiently produced. Finally, I can say also, because today the presenters before me also mentioned about some activities promoting sustainable building and sustainable solutions, I can say a few words about the program which was developed by some leading companies in the steel branch, steel industry, together with non-government organizations and led by Polish Chamber of Steelworks. The mission of this program is, of course, education and promotion of generally steel, but mostly sustainable steel currently nowadays. And this activity is, for example, the lot of let's say, workshops for students, but not only, of course, also the webinars, seminars, conferences. We also organize technical trips and site visits. So also we established the new tradition in Poland, Polish Steel Days. Last year, that was the 5th edition. the topic, there are some kind of a conferences to which we invite the leading companies, the leading personalities, giving us some case studies, some experiment, some kind of experience with, for example, the developing sustainable solutions, mainly for steel structures. This is important to mention, having a lot of architects here, because, of course, the majority of the activities currently are organized for civil engineers, for generally structural designers, but of course we understand the leading role of architects and the decision-making process made of architects, which material will be the leading for structures, for example. So that's why that will be very good if some, let's say, student societies or let's say that organizations which were mentioned today before my presentation, that we can cooperate together, promoting, for example, sustainability in building. Concluding, because I know that there is the very quick presentation, so concluding my presentation, I can say that advantages of modern structural steels prove that the durability, versatility, and recyclability of steel align with the sustainability principles of architectural and structural design. This allows architects to create incredible projects that meet the ecological needs of the current and future generations. New developments in sustainable steel should be adequately disseminated among various professional groups, which I mentioned before: architects, structural designers, civil engineers, investors, and also students who are our future. Yes? And some activities of the steel construction industry, which I mentioned before as a Build with Steel program, help to share such information, providing possibilities to learn about the solutions based on sustainable steel in practice. So thank you very much for your attention. This is the contact for me as a representative of the group of 3 authors, and also information about the website, and also there's more information about Build with Steel program. You can find also on social media and LinkedIn and Facebook. So I hope that our cooperation, the civil engineers and architects, can take more being able on responsible, sustainable materials. So thank you very much. And if you have any questions, of course, I invite you.
Thank you, Professor, for this talk. I have to say that we face increasing interest among our students. I was reviewing just a few months ago one diploma, and it was based on the idea of reusage of steel beams. So we are developing this, but we hope to collaborate in the future, I think. So thank you very much for your talk. Now we have a short break, 15 minutes, and we will complete our meeting with the session 9. So we will meet in 15 minutes. Hello, everyone. Again, we will continue with block 9, and it will be the last block, the session 9. And we'll start with the online presentation. Slava Stopul and from Belbek Bureau, Kyiv, Ukraine. Ukraine Villages Digital Tool, preserving Ukraine's rural architecture with the help of parametric design. You can begin. Let's check if we can, yeah.
Yeah, could you give me a heads up if you can hear me?
We can hear you, but we cannot see the presentation yet.
Absolutely, I will share it in a second. Do you see it now?
Yes, now we can see. You can begin.
Great. Great, thank you. Hi everyone, I'm Slava Stopul, digital architect in Belbek Bureau, and today I have the honor of presenting several of our projects. Probably we could even call them the most technological projects in our practice, and we'll also discuss a little bit how they are supposed to address the consequences of the war that's ongoing in the country right now. So first of all, it's important to mention that our studio prior to the war was mainly well known for our interior design and architecture projects. We did projects globally, and one of the most famous work ranges from prior military arsenal turned into a food hall in the center of Kyiv. We also renovated a church in San Francisco, and even designed art installation for the Ukrainian polar research base all the way out there in Antarctica. Unfortunately, on 24th of February, Russia happened, and as soon as we got our families and friends in safe places, we started thinking how we could employ our skills and knowledge to help envision how the Ukraine will be rebuild and how we can preserve the culture and help people as much as we can. And one of the projects that we started was called Reclaim Villages. As soon as Kyiv region was liberated from Russian forces, we saw the level of destruction, and we saw immediately that people didn't really want to wait for any big strategy on how the whole Ukraine will be reconstructed. They just started doing what they could with the materials that they could find right on spot. And the situation was unfortunately that in case of public buildings such as schools and universities and hospitals, they were rebuilt with the help of local municipalities, the local government, but the task of rebuilding and reconstructing the private houses was pretty much left to the owners themselves, which posed a huge problem because there were so many houses damaged or completely destroyed. So this is how IDEA started, and our two main missions were to give people the tools and help them rebuild as fast as possible using their own capabilities, but also inspire them to preserve the distinct cultural traditional image of the Ukrainian village. We did not want to allow or didn't want to foster the reconstruction of Ukraine in American dream style villas that have nothing to do with our local context. So in case you've never heard of this project and you never got to use our tool, we'll have a quick look through how it works, what it is, what it means, what you can get out of it. And it would be appropriate to start with the fact that we design or we develop design codes specifically for every separate region in Ukraine because the architecture is very characteristic, it's very unique, it's very distinct. And so we develop design codes for every region separately. And Ukraine, as you know, is huge, so there are many peculiarities that we need to address. And once you select the region where you'd like to design your house, you would be forwarded to it really depends on the region, so like 8 or 12 steps where you can configure your house. You would start with a floor plan, and then you continue to roof type and porch, different decoration materials, also probably facade finishings, really the set of possible elements differs from region to region. And here you can see how the final house is configured, and the user is supposed to change the color scheme. At the last stage, you will be able to download an absolutely free PDF that contains all the documentation necessary to build the house, understand the house. And the PDF is comprised mainly of the screenshot of your selected house, the custom-made drawings, floor plans, roof types, sections, elevations. Everything is custom-made specifically for your house. We'll talk a little bit more on it later on, how it is possible and how we achieve this technologically. Of course, you will get the color scheme and an opportunity for your kid or little ones to explore some other opportunities and color it themselves. And after this custom section, you will also be presented with roughly 70 pages of technical documentation, everything including very detailed sections, all the elements that are included in this design code with all the dimensions, basically all the necessary things that you need to know about this region, about the research, but also about the house that you selected as well. So now let's talk about how it was actually made. We mentioned previously that it was one of the most technological projects in our history of our studio. So first, we have a bunch of researchers and architects doing field trips. They basically go to the region that we're currently working on. They take lots of pictures. They talk to locals. They measure things. They sometimes even take the palettes to compare the colors and get the proper ones. At the same time, we do research online. There are plenty of marketplaces in Ukraine where you can actually find a house being sold on a platform in the region where we doing the research. So we would just go on the website, find some floor plans and use them to get a broader picture of what the architecture looks like, how it functions, what is important for people, etc., etc. And once we have all our findings, we put them on Google Drive, and that's where the process of categorization takes place. We categorize everything from different elements, but also color schemes. We gather all this information. You can see this on a example of one of our mirror boards, basically a bunch of pictures connected with lines that our researchers use to make sense out of all this mass. And eventually, we shift our focus on identifying the most prevalent objects in every region, and we try to limit the selection of all those objects to a feasible amount that we can program and then present to the user in our interface. Usually in one category, we have up to 5-6 options, and the set of categories of different elements really differs from the region. So as soon as we have the final collection, we turn all the images to 2D drawings, and we really pay a lot of attention to proportions and details and all the cultural backgrounds of those elements. We develop guidelines on how different elements can be combined, how they work together, what different conflicts might appear in several occasions, and how to deal with them. And when all the 2D drawings are ready, we turn them into 3D models, and this is basically a screenshot of how our collection for one region looks like. And here it will be very important to note that we not only have the geometry itself, but we also augment it through what is called BIM technology. It's building information modeling technology. We use the same principle, although it's not exactly that, but we sort of inherited the idea from that sphere. And what it allows us to do, it allows us to describe what kind of geometry it is. So is it a porch? Is it a window? Is it small one, big one? What kind of material is being used? And also, we augment the geometry with the corresponding projections of 2D drawings from different sides of the object. This will come very handy when we talk about more technological processes, but it's very important to keep in mind for now. So once we have all the collection, it's augmented, it's finished, the really big question is, how do we combine all the possible elements with all the other possible elements to create the multitude of options of the house? And how to do this, not having to model every single house with our hands manually. And just to give you a context, just in Kyiv region, the first region that we've ever released, we've counted more than 200 million unique options, unique configurations, using just the object that we used in that design code. So we have roughly 5 different options on every stage of the constructor, and when we run the mathematics and calculate all the possible configurations, we come to this number. Of course, it would be not possible to model 200 million options by hand, and the answer that we found to this technical task was parametric architecture. Now, of course, when we talk about parametric architecture, we imagine some crazy form finding, some topology experimentation. We imagine curvy facades and extremely expensive projects. But in our case, we use parametric architecture a little bit differently and for a different purpose. So let's go through this just to get a gist of it. What you can see now on the screen is a screenshot of what is called a visual programming language called Grasshopper in a 3D modeling environment, Rhinoceros. Now, it sounds a little bit fancy, but what it basically allows us to do is it allows us to apply the same functions to geometry that you would usually have access to in a regular modeling environment like AutoCAD or 3ds Max, but it allows us to do it programmatically and algorithmically. And so the resulting geometry is basically described in terms of algorithms, patterns, codependencies, correlationships, parameters, equations, etc. And if we want to change anything or introduce any change on any stage of the project, even the latest stage of the project, we can do it easily by changing one of the parameters, and the whole model will adjust to it. So what it allows us to do is to not start from zero as our previous ancestor architects had to do with pen and paper, where they had to redo everything from the very beginning. So yeah, you saw an example of how it looks in the visual programming language. Sometimes we also use Python and more standard coding in case we need to advance some algorithms or optimize something or expand the functionality of the Grasshopper itself if it doesn't come out of the box. And this might look a little bit confusing, but this is basically what our entire code for this application looks like. And for those who have never worked in Grasshopper and have no clue what's happening on the screen right now, basically every dot stands for some specific function. And if you see some specific clusters on this image, some of them are responsible for modeling the house or collecting all of our objects and comprising them into a house. Some of them are responsible for coloring the house, and some of them are responsible for creating the PDF and all the drawings from the model. And again, it's very important to note that everything is codependent, correlated, everything is interconnected, and this is what allows us to be very flexible in our design. If we want to change one part, we can do it very easily, and then all the other parts will adjust. And so this is how basically we take the collection of objects, write algorithmically some rules that guide how the object should be placed in the house, and this is how the whole process works. A bit more visual explanation would be, let's say we take one of our floor plans and we raise the walls, we cut out the windows, we cut out the doors. The algorithm reads out the outline of the house and creates a roof on top of it. It understands what side of the house the entrance is on, so it places the porch right there. Also, the windows get sort of magnetized to the openings in the walls. The decoration, the different decorative elements also know their place. We have several algorithms that identify the walls and subdivide them into panels, which would be extremely cumbersome to make by hand, but one algorithm basically makes all the job for us for every single size of the house, plan, all the different options of how the windows should be positioned. And finally, the house gets colored in a specific color scheme that we designed previously. a very, very important note is to come back to the thing that we were talking about a bit earlier. If you remember, all of our models, 3D models, augmented with their corresponding 2D drawings from different angles. And so when we position one of the objects in the house, so let's say a window or roof type or porch, the corresponding drawings get placed also in that same position. And that's how we get one model that is a 3D model of the house that you can see on the website and you can interact with. And another side of this model is a collection of 2D drawings that later served as a base from which all the drawings for the PDF are made. So here you can basically see how this image in projections could turn into what we saw on the pages of the PDF. And one of the biggest questions is, how do you actually turn this code that's running locally on some of our computers, how do you connect it to the website? And this is what ShapeDiver plugin for Grasshopper allows us to do. We basically take our definition or our code, a different name for it, and we give it to our web developers, absolutely amazing team, entire framework. They use this plugin to connect our code to the actual website, and that's how you get the experience of our online tool. Now, so far we've released 9 regions, and it's been, and it's been quite a process. We started 30 people, 5 different CAD programs. It was absolute mess. We were like trying to communicate between all the different mediums and then trying to get all the drawings straight. It took us 9 months to develop the first region because it was a new process that we had to optimize and see what works and what doesn't. And it took me personally, in terms of coding, more than 1,300 hours just to develop everything that you've seen previously on the previous slides. As of today, we only stick around with Revit and Rhino. That's the most viable option for us in terms of workflow. And the lost regions, the timeline for lost regions was 2 regions in 3 months. Later on, in the following year, we're planning to release 2 regions in 1 month, and we're going to optimize the process even more. And all of this is really possible, mostly due to the coding and technologies. Nowadays, we spend not more than 40 hours of coding per region, so we do not rewrite the whole code. We just make some tweaks and some fixes, probably add some functionality that is required in a specific region, and that's practically what we're left with. Now, to recap this, it was quite a lot, but to recover it in one slide, basically we use Rhino for creating 2D drawings, 3D models, and augmenting this geometry. We give this collection of geometry to the Revit file, where an album of technical drawings that we talked about earlier is created. Then Grasshopper is responsible for taking all the elements, combining it into a building, into a house, and our web development team using ShapeDiver plugin connects all these parts to the online configurator that you can later use and access. Coming back to the BIM technology, it helps us a lot to optimize the processes, not only for the online configurator itself, not only for the work that we're doing in Grasshopper and combining all the elements in one house, but also really helped us optimize the creation of a PDF that is roughly 70 pages long. We have a different script that is designed by a different digital architect working with us that primarily identifies how many objects of each category we have. Let's say we have 5 windows, we have 2 different types of porches, and the algorithms creates all the different pages in the Revit file for those specific objects. It knows how to position them on the page and knows what kind of geometry it is, so it can put the right title under the object. And eventually, when we launch this algorithm, it creates the document that you can see on the right. It's just one page, so it's just an example, but basically it creates a page for every single object that we have in our collection. And here you can see that all the text is already in place, all the objects are already in place, all the details are loading up. And the only thing that architects need to do in this case is correct some mistakes, because algorithm doesn't really get some of the things sometimes, so there might be some mistakes, but architects easily can fix them. They can add some more digitalization, they can make some artistic choices if something might look better in a different configuration, and that's practically it. So the image on the right is what we get straight out of the algorithm, and the left version is an augmented or reworked version by an architect that then goes into the production. Now, as you've seen, all the development process is already pretty optimized and automatized to edge, so we have no problem with that. It's very fast and very handy. But what concerns the research part and the data collection part, it gets a little bit tedious. So we started working with Ukrainian technical universities that were quite interested in our project, and they offered us several examples of how we could work around this issue. Basically, I have no clue what's happening on this slide. This is the slide that they gave us. But they offered us to employ several algorithms that might be called artificial intelligence to mine data or images from the internet in the specific region that we are researching and working on currently. The algorithm will gather lots of data, lots of images, and then in every image, it would recognize the objects. As you can see here, it differentiates between the roof type and the walls and the windows. It would see those objects, categorize them, and give us architects sort of summary and statistics on what are the most prevalent objects, how they look, what they like, how they combined. And in this way, we as architects will spend less time on the actual gathering of data, but more on the analysis and understanding what it is, how it should be, and what we can do about it. So this is amazing. This is only in work. This is only work in progress. There was like several test runs, but we're very much looking forward to using it a bit more and developing the algorithms further. What is important for us is when we released the 9th region last week, we're trying to communicate more and more with local authorities and with private owners, and we want to understand how they actually use the tool, if it's actually useful, if it's actually usable, what kind of profit people get from it, what we could probably improve a little bit. And so the first, just an example, first feedback that we ever had on this tool was that our initial floor plans that we presented in the first region, the Kyiv region, they were very much precise in terms of how it worked previously, historically, culturally, traditionally, but the floor plans were not really accustomed. They were not, they didn't work for modern needs and modern style of living. So people texted us and we said, all right, no worries. And we created a whole new set of more detailed open plan floor plans for the reposition. And we did it for every possible size, and we did multiple options so that people who want to rebuild in a traditional style in terms of facade, in terms of the overall look, could also have a very comfortable life inside and could have all their modern needs met. Now, when we're talking about the future plans, as of now, we have almost 9,000 houses generated on our website. Unfortunately, we have no real method of proving whether people actually build those houses or not, unless they proactively reach out to us and tell us that, you know, we used our tool and we rebuild it. But as of now, as I said earlier, we released 9 regions. 2 of them were made in our own financial efforts, let's say, and then 5 of them were released with the help of US aid, and 2 of them were released with the help of Eastern European funds. we're actively searching for new partners and funding and people who are just interested in the project and would like to help us in any possible way. We're always very open and we change things almost every single region. So if you're interested, please reach out to us. We would be really glad to hear out what how we could collaborate and use each other's experience and expertise. Here's our lovely team. Unfortunately, we have too many researchers to put them on one slide, otherwise it would be not comprehensible. But absolutely every researcher and volunteer that joined us has our immense gratitude and appreciation, respect, and love. So yeah, and in terms of speaking of the most technological projects in our practice, we also wanted to note just one more. We have like 4 slides left. I hope I'm not stretching out the time. Okay, it's 25 minutes, pretty good. So this is a 3D printed school in Lviv, and it is a project which was initiated by the Lviv municipality and supported by all the great organizations and companies that you can see on the bottom of the slide. The basic idea is that we already talked about the level of destruction of private houses and private property, but also the schools suffered a lot from Russian attacks. And unfortunately, the demand for reconstruction, renovation, and construction of new schools is not exactly met with the same supply of funding. So there's a huge demand and surge for new technologies, new methods, new ways of constructing efficiently, fast, with great flexibility, with great sustainability in mind. And that's where the idea of 3D printing came about. So this building is, it comprises 500 square meters area, and it might suit or fit 100 students in 1-story, 2-part building. It was printed in roughly 40 hours, so like a working week, basically. And what is important to mention is that 99% of concrete was locally sourced. Now, in terms of process, usually in such cases, 3D printing takes place on a factory, and then from the factory, the prefabricated parts get transported to the site where they get assembled. In our case, unfortunately, that was a bit tricky because of the logistic issues and all the unpredictable environment. Sometimes it's very peaceful. Sometimes Ukraine sees massive attacks from Russia. So the decision was made to bring the printer in Ukraine to Lviv, and actually it was positioned on the site and 3D printing happened on the site. The building itself, the size of the building and the design of the building was largely predicated on the size of the printer itself. So the design was thought out in the way that would maximize the area of one print. And that's why the printer had to be moved several times across the site to finish the building. Unfortunately, moving the printer itself is somewhat expensive, but considering all the different options, that was the most viable choice in our case. So that was it. And as of now, we are our team is working on installation and further works that would finalize the house. So hopefully we'll see it finalized in the nearest future. And thank you so much for listening and bearing with me for half an hour. If you have any feedback, any comments, any critique, any suggestions, we would be very glad to hear you out on any of our platforms. We are pretty much everywhere. We have a website, we have Instagram, Facebook, LinkedIn, whatever. Please give us a note, reach out to us, and we'd be happy to see how we can work together and collaborate. Thank you so much for your time and have a lovely Tuesday.
Thank you so much. Let's keep in touch. Since we have you online, I have the proposition to maybe be open to a few questions, maybe 2, or if you have any, please raise your hand if you want to ask. No questions. Okay, yeah, okay. Thank you.
Hi, hello. Thank you for your presentation. That was a very interesting project and a lot of work. I'm wondering what is the next step? So what do you want to do with this application? Do you want to custom sell such kind of houses, or it's just for historic preservation? Yeah, what plans do you have?
Yeah, that's a great question. We've been asking it for quite a long time, actually, as well. So the idea started from helping people reconstruct their own houses. So we are not selling those houses. We are not responsible for the actual construction of the house. We are providing the guidelines for people to make as few decisions themselves as possible. So we as architects see some value in the culture and the cultural elements and all the decorations and having proper floor plans, right? That accustomed for accessibility and et cetera, et cetera. So we provide guidelines for people to have a proper design, and then people can use it or they cannot use it. It's more of a recommendation type of project, but we would really like to, in terms of speaking about the future and where it's going, first of all, our plan, as we said, is to release another 16 regions and cover the whole Ukraine so that everything is preserved and we have at least this cultural code preserved in some place in a systematic way. But also, we would like to start the conversation with municipalities, local government, local authorities about how the villages will be reconstructed and restored in the future, and our tool may be used systematically across the board to address this issue so that the reconstruction is systematic and not one-to-one cases. I hope I answered the question to some degree.
Okay,
I don't know how much time I have.
Thank you so much. We'll continue with our speakers. Thank you for your time.
Thank you so much.
We will go to the next presentation, Raw Earth 3D Printing as a Solution for Future Settlements. Joanna Klimowicz, Anna Nowak from the Warsaw University of Technology, Faculty of Architecture, Poland.
Good afternoon, everyone. We would like to shortly show a bit of our work related with the raw earth development and designs. Being honest, I'm very honored because I was surprised that professor who entered this conference started from the subject related with the raw earth construction, and also he showed at the beginning, maybe not the same picture, but picture related with the historical building on the earth, the Great Wall in China, which was previously made by the raw earth, created by the humans. Later on it was designed, but a little bit different types of the technology, mostly from the bricks, but they also made from the earth. So those technologies are very well known all around the world. We realized that this type of the construction and this type of the buildings are very well known around the world, especially in the Middle East, in Africa. Most of the vernacular architecture are based on this type of creation of settlements and the buildings for citizens. Here you have the example of Syrian people which are settled the desert in Syria. Here the example from Africa, from Burkina Faso and Ghana and also Cameroon. Some of them are using the special type of the ornaments which are dedicated to those group of the people which are settled this type of the arrangements. Both of them are handmade, I'm sorry. So because we are involved in such kind of the construction in our faculty, we started to think how raw earth has impact on the carbon footprint of the building, and realized that this type of material is on the bottom of this triangle solutions related with different types of materials dedicated to construction and building materials. A lot of other professors and teams are involved in special types of the arrangements and research related with different materials dedicated to the buildings. And those are some examples of prepared by them the analysis, especially related with the energy requirements and the thermal accumulation, because this is very important nowadays when we are facing the problem of the climate changes and the phenomena which are, for example, the heat waves and urban heat island, quite very often appearing on the, for example, cities. Those are two examples of buildings. One of them was made first, the design at our faculty. The design was prepared by Jerzy Górski, Professor Kelm, Teresa Kelm, and Marek Kołłątaj, and it was built at the beginning of the century, mostly in 2008, 2007, made of the rammed earth construction. I was involved in the part of this construction on the field. And on the right side, you have the example of the same solution, maybe not the same solution, a similar solution, the building made freehandly by the students from Oxford in Michigan in United States. They, under the supervision of Mrs. Peggy Sauce, they created this building by creating the small balls of the earth, and they putting one above the another. They created this unusual rural settlement for the people, mostly for the vacations. Those are some examples of the previous type of the arrangements of the settlements. Nowadays, we are trying to jump into the more sophisticated and more new technology type of creation of this type of buildings using the 3D construction, mostly of the raw earth and the straw as a stabilizer.
Yes, exactly. And of course, different contemporary architecture now, they are a little changing according to the raw earth technology. And going forward, we can also see some designs and projects done by famous architects, one which is also the winner of the Pritzker Prize, Kara. He designed many buildings in the rammed earth technology, and we can just see that also this material has a new way of design, new aesthetic part. And as it is here visible on this example, the double layer can be also combined, not only the compressed stabilized earth blocks, but also combined with other materials, as is in this example in concrete. And compressed stabilized earth blocks in this example, they are used from the interior part. But of course, also using in situ cast walls, we can create different architecture. As you remember, I think Kara is from the Burkina Faso, and many of the designs of his projects, they are just placed there, and local clay mixed with cement and aggregates. Of course, cement as a stabilizer, but we can just use different stabilizers. They can be also visible in many contemporary examples of architecture. And according to the 3D printing, going forward with the 3D printing technology, of course, using with with possibility of using the 3D printers. We have the pump, we have the special mixture of the earth, of course, with the different types of the stabilizer. So it's the cement, lime, hydrated lime, and also some ash and powder from, for example, for cutting the stones, but also some polymers can be also added during the 3D printing, and different types of the 3D printers, they can just place all of the buildings, but also some bricks, some elements, which we can just also easily use. And one of these examples is also the Institute for Advanced Architecture of Catalonia, when they tried to 3D print the bricks, made from clay also and from earth, with different, which were differently analyzed and differently shaped according to their thermal heat properties. And of course, layer by layer, all of the elements there were differently designed, and each of the facade could be done in a little different way. At the end of this project, they printed also the prototype using earth when they tried and fixed how it should be done. And of course, as it is quite common when we don't want to use so many stabilizers, we have to use also the quite huge eaves to protect the earth structure against the moisture and water. And one quite famous is the Tekla house building, which was printed from the earth with using the crane, special crane designed by the World Advanced Saving Project. They used the three trusses which were connected with the arm, robotic arm, and of course the pump. With using such solution, they are able to make different models and make the bigger scale of 3D printers, which was quite problematic according to the areas that can be produced in the 3D printers. And as it was mentioned, earth is mostly one of the material that is mostly during the construction site is a part of the waste, because on every construction site we are excavating the ground, we are digging during the foundation part, and this we producing the waste. But this waste can be also a part of the building, it can be used as a building material. The 3D printers will allow us to minimize the material consumption and also to create different types of the buildings, different types of the elements. And with using also this part with the circular economy, I think it could be also quite sustainable solution. And as you saw, I hope it was also the contemporary use in architecture right now.
So that's why for us the possibility of creation of 3D modeling, especially dedicated to different types of the settlements, is quite important, because from the economical point of view and from the creation the good place for live without involvement and huge amount of the money is quite crucial. So that's why we would like to explore this part of new technology related with very, very old traditional vernacular type of creations, the building. Thank you so much for your attention.
Thank you.
Thank you very much for this valuable insight to our conference. And we have next speakers, Jakub Bombik and Krystian Kwieciński, Warsaw University of Technology, Faculty of Architecture. And the presentation, Computational Form Finding and of Acoustic Surfaces for Increased Patient Comfort in Hospital.
Okay, hello everyone. First of all, I would like to thank you for having me, and I'm glad to be here. So, I would like to begin with provide some context why I chose this topic. So, hospitals play a crucial role in our healthcare system. Designing those buildings is pretty challenging, especially in terms of acoustics, which are often underestimated. As it turns out, noise can significantly affect patients' health, for example, causing problems with blood pressure, heart rate, cognitive function, or sleep quality. In this slide, you can see several scientific articles that show how the noise in hospitals is an important topic. The researchers refer to recommendations, to WHO recommendations that recommend noise level in hospitals at 35 decibels in therapy in the observation room and 30 decibels in wards. However, in practice, those noise levels in hospitals often exceed those values. From those papers, we can also learn that there is many sources of possible sources of noise in hospitals, but as it turns out, the most difficult to deal with is the human factor, the noise generated by personnel. So this is so the project took into consideration only that factor. When it comes to basic noise control solutions, acoustic panels are the most commonly used. Any in-depth acoustic analysis of digital models during designing stage or optimizing an already existing sound environment is mostly the subject of single scientific study. More advanced solutions tend to be expensive and difficult to implement. On this slide, you can see many, over 60, as you can see, models of acoustic panels that find use in hospitals. Now, this is my own research for further to serve as a reference base for further development. But for further research, from this table you can learn about some panels' size, price, materials, and what's most important, the absorption coefficients for given frequencies. Knowing all that, the project assumed a creation of its own suspended ceiling structure. As you can see, the structure was tessellated into triangular grid, which every vertex was attached to a linear actuator. Beneath those actuators, there is a layer consists of flexible material on which, in every triangular cell, the triangular panels made from mineral wool were mounted. The whole simulation, the whole research started from the very simple model. It's like a shoebox-shaped model with two windows, doors, and 2 hospital beds. Of course, also our suspended structure. The situation we studied shows nurse speaking to patients, and the second patient is our test patient, is behind the nurse. Here you can see some spaghetti, but in fact this is how the simulation looks like. It is based on a ray tracing method that sends rays from the source and collects them in the receiver after a specified amount of reflections. In our case, there were 6 of them. And to get back, and the source of the noise was placed at the nurse's mouth level height, and the receiver at the test patient's pillow where his head should be. Moving on, the whole algorithm is tailored on the desired speed, which means the fewer rays counted, the larger the receiver is, and the faster process. Nonetheless, the larger number of prongs will give us more accurate results. On this picture, you can also see the whole rays that hit the receiver eventually with the power, because every ray carries a power expressed in watts that is then counted at the receiver and converted into a noise pressure level in decibels. And here you can see the cross-section through the situation I'm talking about. As you can see, this is something like the control group of our research, because as you can see, the ceiling is completely flat, so it's similar to solutions that already existing. And the sound pressure level measured at the receiver was at level 33.42 decibels. During next simulation, we turn on, in addition, an additional algorithm, the evolutionary algorithm, whose task was to find the best possible ceiling geometry to reduce the noise level. So, as you remember, I hope so, each vertex of the structure was attached to a linear actuator. So, in this case, we unlocked every vertex, and so it could move within a certain range in z-axis, and leave it be, leave it for the optimization. And in that case, the sound pressure level dropped by 3.2 decibels. In this slide, you can see the whole logic behind my algorithm. I won't explain in it more detail, but what can I say now, that it is still under development, but yet it gives us promising possibilities of iterative sound optimization, something not available on the market today. The whole structure, the whole algorithm is written in Grasshopper, using already existing components and own components written in C# language. And now I would like to say a few words about future work and conclusions. So, in the next phase, I want to deal with the development of three options that would include the use of machine learning. So the first option is pretty similar to the one I discussed in this lecture, but it is more complex. It will conduct multiple analyses, not only one, to find the most optimal structure for the entire daily rhythm. The second one is more crazy, because it will use dynamic structure adjustment with automated actuators based on neural network decisions, because I didn't mention that, but I think I should do it. So one optimization takes about 2 hours. So it will be nearly impossible to adjust the structure in real time. So we'll have to think about AI approach to develop some neural network to make the decisions for us, to find the most optimal structure for given time. And a third option is a hybrid approach, adjusting structure at specific times of the day. And now I would like to say a few words about what we have been doing recently, because more than a month ago, I started working on a research method involving a reproduction of existing hospital room, being more precise, one of the Reha Sport clinics room in Poznań, in cooperation with one of the founders and the professor at Medical University in Poznań, Tomasz Piątek. The first steps consisted of detailed inventory of the room and a series of tests during which average values of acoustic pressure were measured. And here we can see one of results of such a test that shows us average acoustic pressure of a conversation with the patient laying next to the test patient. So that's the data collected from the real situation. Next step will be to recreate all of this situation and the whole room and proof of concept of my algorithm. Thank you very much for your attention.
Thank you very much. And we have the last presentation online, hybrid online, I think. We will have our colleague reading and our guest that will begin in French. Hello, can you hear us? Disconnected. Okay, let's wait a moment, because do we have the presentation? Ah, the movie.
Say a few words about our special guest, Luc Scoiten, architects from Brussels, very well known by his beautiful drawings, utopian architectural and urbanism drawings. And he prepared for us today his history of his life, of his professional life, with showing the idea at the beginning of end of 60s and the beginning of 70s, 20th century, and his professional life was born at 68. The special hippie movement, and the day that people start to realize that we are responsible of our planet and the environmental crisis that we can have, and that we this time had at the beginning of this crisis. So. I hope that we will have the connection. His drawings are really interesting and special as a story, beautiful story for everybody, and very poetic and very delicate light. And he imagined the city as a natural environment based on the natural shape and natural form, we can say. One moment, I will check what has happened. Okay, so we are waiting for the moment. I'm sorry, the technical problems. And he's not only the architect, he is the person who organized a biomimicry group of architecture in Europe. He prepared a lot of special drawings, but the architecture too, some building he want to show us, prepared by using the natural materials, especially wood, timber, and which he made by his own hands. So it could be really nice. And of course, he has a big influence on architecture of today, if we think about biomimicry architecture, the architecture strongly connected with nature, the architecture of natural materials, the architecture which is strongly combined and linked strongly with surrounding with the nature and environment, and of course which help this environment to survive with us. Okay, we are waiting. So you can, the most well-known the idea of Lux Coiten is city vegetal, the city of plants, we can say, or the city of the trees too. It's two ideas, similar ideas, and his inspiration is he find in the nature. Okay,
Yes, we can
so
see you right
yeah,
now.
we can see you. Hello, hello. Bonsoir, Luc. Comment ça va? Ici Kinga. Bonsoir. So, je sais que vous voulez nous montrer le film premièrement, oui, c'est ça? Le film qui dit un petit peu à votre vie, à votre profession d'architecte, urbaniste, bien sûr, d'architecte qui image l'autre, qui a très très grand imaginaire. C'est ça? Ou bien on... Oui. Et après on va présenter votre diapo. Je vais ajouter la traduction de votre texte, ok?
Très bien.
Ok. So, on peut commencer avec le film, s'il vous plaît.
Oui, très bien. Le film est chez vous, je pense. C'est vous qui le lancez.
Non, c'est pas moi, c'est vous qui nous montre le film.
Je n'ai pas préparé de film, j'ai juste
les présentations?
Les diapos, oui.
Les diapos, ok. So, on va commencer avec les diapos.
Très bien.
Vous pouvez montrer le diapo?
Oui, je lance ça. Alors, il faut faire le partage d'écran. Vous voyez?
Moi, je vous vois sur l'écran, mais je ne
vous
vois
voyez
pas votre écran.
Oui, donc il n'y a pas le partage d'écran.
Il n'y a pas de la partager l'écran?
Oui, un instant. Voilà, partager l'écran. OK. Et maintenant...
Vous pouvez partager l'écran ou
oui,
vous,
oui,
ou
un
vous,
instant.
Voilà. On voit très bien.
Comme ça.
Comme ça. Alors, on commence.
Très bien.
Oui.
Donc, la manière dont j'ai commencé à réfléchir comment je pouvais communiquer sur un autre possible pour notre futur. Pour moi, c'est le dessin qui est le mieux approprié pour arriver à montrer ce qui pourrait nous arriver de mieux. J'ai donc choisi de m'exprimer en projetant cette vision d'un futur écologique dont la nature est vraiment l'élément qui va permettre d'envisager un futur positif.
Alors, Luc, he decided to show us his idea, the nature, sorry, the nature combined with our place of life, and he's show us his dreaming and his idea how the future city and future life could be like. The drawing has remarkable quality, and the language of Luc Scoiten, how he communicates his idea is by drawing. It speaks all languages. The drawing speaks all languages. It allows us to instantly understand what it's saying. If I had to describe everything in one of my drawings, it would take hours, and the evocation that would be built in your head would not only be less precise, but also different for everyone. For this reason, I choose to communicate mainly through images, but also because my different hypotheses of the desirable future that of a new age were constructed form a visual imagination. I see my drawings as an invitation to share with you this vision of a future very different from what we find in the media. It is a way of inviting you into my imagination, of opening a wide door to the utopia of an immensely ecological, biomimetic, sustainable, and optimistic possibility. I began my work as an architect in 1975 with research and experimentation with a lifestyle entirely focused on a close relationship between nature, local bioclimatic energies, and housing. The challenge of this realization corresponded to choice that we are too personal to be sustainable for anyone other than my little family, and the particularity of my project could not succeed without a self-construction project. The first house was also influenced by the events making the time, May '68. The Understand and hippie movement, the first oil crisis. My references were not the existent example, but essentially our needs and the personality of each person. Luckily, at the time, the very first solar panels had just come onto the market, and the company that manufactured them didn't have a convincing example of a house designed from the start for harmonious integration. It was thus able to benefit from... Yeah. Yes.
Excusez-moi, je ne suis plus. Je devrais chaque fois passer les images en fonction de ce que vous dites, mais je suis je ne sais plus, je ne sais pas où vous en êtes.
Ah bon? Vous devez changer des images parce que je... Oui.
Vous me dire le numéro sur lequel vous êtes et alors je peux avancer.
Quatrième numéro. Oui.
Ok. Et chaque fois que vous...
Okay, je veux dire quel numéro j'écris. OK?
Parfait. Merci.
It was thus able to benefit from 80 square meters of solar collectors free of charge. The same was true for the wind turbine. My goal was to cut the umbilical cord that connected us to society, towards which I had a lot of disturbance. I didn't want to owe my energy to a nuclear power plant, but to feed myself with all the resources of the bioclimatic environment. 5. In the basement, a well-insulated tank of 100 3,000 liters of water provided me with winter heating tanks to the calories accumulate throughout the year. Cs. The staircase, the doors, all the furniture were made by me with unstraightened boards from the forest right next door. 7. The half-wooden joints were made with a few rudimentary tools. The longer this interior design work continued, the more I felt an integral part of my place of residence. Wit. At this same time, I began to think about the outcome of my work as an architect would be. If I had the technical and financial means to create a house freed from the technical constraint of its construction. So I set out to design homes that are completely in tune with life. 9. These natural habit studies have been grouped under the name of habitants because they all revolve around the framework of living trees with shape guided by stretchers, stakes, prunings, and grafts. All these drawings have accumulated for years in my drawers, and then times change. People find it worth communicating. D. The slide, the diapo D. After the Orezona house, I built my first architectural studio with the help of architect interns, a few dozen meters from my house. He was very small. Saving space and energy was already part of the approach. The frames, doors, windows are reused. They have been modified and personalized. 11. In the middle of the space stands a staircase tree, as I imagined it in my first drawings. Each of the windows frames a portion of the landscape, like a view through the branches of the tree. Since the tree represents for me the most fantastic example of a living structure, my model of inspiration, its presence in our workspace becomes obvious. Thus, each of my architectural proposal is closely linked to the place when it is located, to its area, to the soil, to the climate, to the microclimate, to the culture of the people who live there, to the immediate environment, to the fauna, to the flora. Tres. It is with this in mind that I imagine a fall barrier on a Normandy highway as a sort of gateway to this region. In addition to its commercial function, it had to indicate the specificity of the place crossed. In Normandy, vernacular forms are located on land bordered by double rows of enormous fastigate trees planted on an embankment. My toll gate had this feature as well as a green undulation with herbs and grasses, all on contemporary frame. 14. The administrative buildings modeled their typology on the particularities of the local buildings and the cliff of the nearby co-region, characterized by these stripes and with the limestone and the block flint. 15. If I had to design a barrier for another region, I would have used another mode of expression, and the configuration of the entire work would have been totally different. We are the opposite of what is currently happening. A tall barrier is a kind of alien ship that lands on the highway. Completely interchangeable, they are identical in North America, South Africa, or Australia. What is the point of traveling if it is to encounter the same banalist, globalist architectures everywhere in the world? The loss of architectural diversity in favor of a globalist model is a considerable damage if it reduces our built heritage to its lowest common denominator. Says, how can we find a part of nature in urban centers made up almost exclusively of mineral materials? I try to answer this question with different proposals for vertical gardens designed for the urban cankers of Brussels. This said, here, as in many cities, many corners had been demolished and left fallow due to lack of the interest from real estate developers. These cankers have proven to be of great attraction for the advertising in search of places where to extend their mercantile slogans and push us to consume what we don't need, since for our real need, advertising is perfectly useless. When the corner is missing, it is the cornerstone of the streets that collapse. This width. Based on this observation, I wanted to locate small places in these neglected areas of poetic architecture with the sole aim of reintroducing the living, the rhythm of the season, a portion of the landscape. No one of these plans came to the fruits, so it's difficult to construct this idea. This nef. However, the large waterfall project was very close to being completed. It planned to make water flow over rocks from the roof. That wall was made of the only natural materials that the city produces. Its waste used concrete sidewalk slabs. The rocks were mentioned without consulting a trapped lay. The waterfall was powered by solar collector placed on the roof of the hospital. The more sun, the more water flowed and from higher up. 21. 20 years later, I returned to this same theme and I added an additional difficulty, that of housing homeless people there. It is unacceptable to leave people in the street, on the street, damaged by life, abandoned to their home, to their sad fate, in painful and undignified condition. The city must act with empathy towards all these residents. 22. My architecture studio has listed more than 300 small cankers in Brussels and made multiple proposals to show how much the city would gain by rehabilitating this place to house for the homeless people. 23. The construction is prefabricated with biosourced material, mainly wood, hemp, lime, and straw. The roofs are green, as are the exterior stairs. 24. Each landing is at the same time a small balcony which allows the former homeless persons to maintain contact with the street and to find themselves in an environment that they have known for so long, but with an inverted perspective. They watched people pass from bottom to top for a long time. From this home, he will look at the street from top to bottom. By receiving that look, we at the same time reverse the attitude, behavior, and presence of the new tenant. Some of these projects are currently being studied in Brussels. 25. Recently, the center of Brussels has become pedestrianized. For one of these ends, I designed a pergola with a shape inspired by my first Habit Arbor project, Habit Trees project. Its structure is made of welded, constructed iron invented by climbing plants. 25. At night, this meeting place is lit up with thousands of small LEDs scaled through to the foliage, creating works with a strong identity in urban space to mark landmarks, make the city more user-friendly, but also emotionally tie us to a place should be the concern of the planners of public space. 26. Unfortunately, they are concerned with solving technical problems but don't go so far as to give particular personalities to these places. However, this responds to the essential need to feel in tune with one's urban environment. 27. Let's take a step back and take a holistic look at what our future could be. Imagining a desirable future allows us to better see in which direction it is interesting to head today to achieve our goal later. 28. Let's start by remembering what we imagine about the next century. In 1900, a century ago, without a doubt, the year 2000 was going to fulfill all our desires. We were going to benefit from extraordinary technologies capable of bringing comfort and happiness to us all without any fears of possible consequences. 100 years later, our vision of the next century is apocalyptic. What happened to go from such an idyllic vision to such a nightmarish vision? Answering this question will help us see a little more clearly out future possibilities. 30. Obviously, the Earth is in bad shape. Global warming is one of the great dangers facing us. This is not the only one. The raw materials essential to industrial civilization will almost all run out in the century. 31. Added to this is the storage of fossil fuels, including nuclear power. What do we do when we no longer have enough energy to power an industrial civilization? To change the paradigm, we will still need fossil energy. It is therefore high time to see things completely differently. The concrete that we use widely for our construction is an ecological disaster. It is the second largest contributor in the world to greenhouse gases in the construction sector. Making concrete requires sea sand because desert sand is not sustainable. The industry pumps in the enormous quantities along the coastline, which then sucks the sand from the beaches, where it is also starting to run out. The attacks on the quality of our environment are numerous and occur constantly. 32. Life on Earth is the result of 3.5 billion research and development efforts. Anything that was not sustainable was not retained. Nature is our mentor. Biomimicry draws inspiration from nature to lay the foundation for the truly sustainable world. In nature, everything works on the principle of the circular economy. Waste is a resource for another living organism. We do not throw anything away. 33. Let's take a simple shell and observe it from the angle of the material. It is a bioconcrete with great technical performance. It is perfectly smooth, waterproof, non-porous, solid. It does not disintegrate. It was made by a small mollusk at the ambient temperature and pressure using materials taken from its immediate environment. And the icing on the cake, it absorbs CO2 to create this magnificent shell with infinitely varying shape and colors. 34. The good news comes from these laboratories which are researching how to apply the same principles to the creation of human-produced bioconcrete. 35. A termite mound is a tower building inhabited by the first city dwellers on the planet, termites. This gigantic building, in relation to the size of these inhabitants, is self-air conditioned. It does not register the degree of the difference between day and night, while the outside temperature can vary by more than 30 degrees. To achieve this same result, we must use a whole battery of technologies, each more polluting than others. Throughout the world, examples of vernacular architecture show us the path to renewable, but we don't seem to pay the slightest attention to it. In Yemen, in Sana'a, a magnificent building of almost 12 floors, completely integrated into the landscape and the climate, have resisted time or several hundred years. The materials for their construction were taken a few dozen meters from where they were built. Transit. The most fascinating thing is observed at the end of their life, when these homes out of the use are deserted. They transform into a magnificent ruin before returning to their original hall without leaving a trace of their ephemeral passage on the scale of the earth. Wouldn't the beauty of our work as architects and urban planners be to design the entire act of building throughout its duration? Can we be ecstatic today about the aesthetic of the building which caused damage to the environment before and during its construction, and which will one day end up in a pile of rubbish in a landfill? Awareness of the state of the planet must lead us to change our outlook, broadening into all the consequences of our action. 38. The alternative to future waste construction are buildings collected from renewable materials such wooden structures, straw or hemp insulation, green roofs or thatch roofs, earth and lime coatings. 39. Thanks to three natural materials, buildings are breathable, like our skin. On the other hand, buildings made of concrete, steel, or other composite use breathing materials. 40. They retain the humidity that we release and require us to install controlled mechanical ventilation to correct this major defect. 41. I imagine for a biomimetic future a home equipped with the tree-like structure and closed by sort of cocoon and organic textile. 42. Although we do not currently have the technical means to realize this prospective vision, I can already project them through drawings. If an architect's plan is on an anticipation of a desired future, drawings an imaginary future is taking the very first step towards its realization. 43. Bamboo is magnificent building material. It grows extremely quick. In 2 or 3 seasons, it has reached its maximum size and can serve as a supporting structure for homes. 44. It can be closed with an organic textile by make homes. 45. A coral massif is made up of multiple living organisms cooperating together to create a resilient ecosystem. Over time, it became richer, stronger, and more solid. I use it as an example to design homes, eco-neighborhood, cities, and ultimately to build an entire utopia based on a way of life in tune with the environment. 46. A large tree is made up of a solid living structure that an engineer would call a column, beams, rafter, supporting nearly a hectare of solar collectors, transforming solar energy into electricity. In Japan, I visited a laboratory equipped with fans powered by photosynthesis, this major principle of life. 47. The city of waves owes its morphology and its architecture to its seaside environment. 48. Waves from naturally in the sea and in the sand in response to the environmental and local aerology. 49. The creation of a seaside town specific to this environmental particularly would draw its energy from the morphology of this biomimetic construction. The design of the home adapting its typology to the particularities of the environment is required in all of my work. 50. The city of roof gardens is built, transformed, and constantly modified from an existing city such as those of today. Raising the city and rebuilding over the ruins would be an energy, economic, and environmental disaster. Our construction still have a good number of qualities. We can improve them, rethink the facades, the terrace, adapt the roofs into green promenade, create positive porosity with climatic impact, the sun, the wind, the rain, while presenting the energy that we captured. 51. Shanghai is a city that is quite astonishing in the speed with which it is transforming. 52. Some days, a yellow cloud envelops the city and makes it difficult for people to breathe. The Yellow River is truly yellow from its pollution. I thought about how this city could evolve, change, and eliminate the pollution it generates. 53. The panorama below is enriched with the fourth dimension. A timeline with dates is placed above the below the drawing. The left side is located in 2000, and the more we move towards the right, the more we move towards the time, and the more we see the evaluation of the city getting closer to sustainable world. The fourth dimension is an integral part of all my graphic research because I feel the representation of city in the form of a frozen frame as amputated of its most important dimension, the time. 54. I choose a district of Brussels to break down the changes into an aerial view over 4 centuries in 5 paintings. These first drawings of Lecken in 19th century was made from multiple engravings and cadastral plans of the time. 55. 100 years later, in 20th century, in the beginning 20th century, the panorama of the city had completely changed. This allows us to better anticipate the importance of changes in the coming century. 56. In the year 200, the city evolved into a situation close to what we know today, with all its problems: intrusive cars, industry in the middle of the residential area, air and water pollution, etc. Second set. In 2100, then better still in 2200, we can discover a new future, committed to reconciliation with the living things inhabiting the planet. 58. Increasing the quality of our life requires the reintroduction of plants into the city to find us in tune with where we live. In the new city, the roofs have been greened. Footbridges allow you to go from one side of the street to another and to walk high up in the city. The canal was covered by a large fish net. A wave is constantly passing by, to the delight of surfers and boarders. The homes are made of bioglass or bioconcrete integrated into a portion of recomposed landscape. Next, second slide. Our large city have food autonomy for a maximum 1 week. What happens when a global crisis prevents stores from being stocked? We just don't have anything to eat anymore. In all of human history, we have never been so dependent on such a fragile system. We are entirely dependent on the globalized balance. To mitigate this major risk, we must make our city more resilient by providing them with a good portion of the food needs. So you can see, next slide, excusez-moi. Next. Many roofs have become vegetable gardens. The trees in the street have turned into orchards. Greenhouses, beehives, hen houses, devo coats have multiplied in all the spaces still fill, roofs of balcony, terrace, courtyards and gardens. Jeszcze parę. Już koniec. Next, please. The aerial view of Lyon was done from a photo of Pardieu in 1960s, commercial districts around Lyon train station. In the futurist vision, almost all of the existing buildings have been preserved. They have been adopted to the design of urban planning, considered as a landscape integrating multiple ecosystems. 62. Yeah. I carried out similar work in the city of Strasbourg. The historic center of the city is magnificent. My thought, therefore, turned to the peripheral district where the housing blocks have spread. 63. The poverty of this so-called social construction has generated multiple problems for residents because it is difficult to build emotional relationship with such mediocre, standardized living space without the expression of the personality of the people who occupy them. We all have a different head. With a wooden, we have a place to live that looks a little like our head, our personality. 64. Based on what already exists, I make proposal to restore specific characteristics of each accommodation in the same complex. 65. Operating only with renewable energy requires saving our energy, which led me to imagine small, very light vehicle better suit to our travel needs in urban areas. This small vehicle takes its current form, an electric rail, and is autonomous. SUA-Sound 6. The materials constituting this machine would largely come from biosources elements. The tram is convoy of dozen small light vehicles. They weigh 200 to 300 kilos for 3 to 6 people. SUA-Sound said, this tram never stops. A module is placed on a siding to let off passengers and wait for new passengers. For more than 10 years now, I have been reading with a machine resembling a tram. SUA-Sound with. This electric machine, a twike, weighs 200 kilos, travels at 19 kilometers per hour, and it's equipped with 2 pedals. Full tanks allows you to travel 100 kilometers and cost €1. It is choose to pedal. I increase the range of my vehicle and I keep myself in shape. I go everywhere with this machine, even on the highway. The electric motor being silent, you couldn't hear me coming, so I added a sound of a horses galloping. Obviously, this surprised people a little. On the highway, this sound is not sufficiently audible. I added the sound of a steam locomotive. When I pass a truck at 19 kilometers per hour and he hears the sound of the steam locomotive, the driver is quite surprised. This machine is not my design. It was made by Swiss students. SUA-9. I designed another model for 3 people. It's registered in the bicycle category, so does not require insurance, taxes, or seat belts. It is equipped with 2 electric motors and biosources wooden shell. SUA-Sound D. The bike's ratio between its efficiency and the energy consumed is unbeatable. It is arise to start from this model and perfect it then to start from the car and simplify and lighten it. SUA-Sound 1. In Brussels, I'm finishing. We are finishing. In Brussels, in my garden, there are 2 large trees. I installed an armchair there suspended from a cable connected to a winch and charged to the ground. I used a small device called biofeedback, a sort of a simplified electroencephalogram capable of determining when I enter meditation. SUA-2. From that moment, the winch turns and I climb the tree into the canopy. From there, I can see the whole city through the foliage. The posture, the state of consciousness, the view, the proximity of plant, the canopy of birds bring me closer to this future that I want and nourish my imagination. SUA-Sound 3. Now, our architecture studio is working on a project to transform a social housing building to adopt its climate change and the ecological transition. We have introduced a very ancient notation into operation, the transhumance of living space following the seasons and bioclimatic contributions. SUA-Sound 14. We do not occupy the building in the same way all year round. It is an aberration of modern life which distances us from our relationship with the environment. On the south facade, we designed to add a buffer space made up of large mud walls to separate the apartments. Passed through ventilation ducts, they seek their calories or their frigories in the ground, like termite moth. It is through the use of many other biomimetic principles that the building functions largely as a simplified ecosystem. 75. The design of the architect's personal home is never trivial. It allows him the full expression of his personality and offers him a place for experimentation and research that could not decently see the light of the day with a client look for an architecture that has already proven itself. At the beginning of 20th century, building has been transformed into 4 apartments, 3 of which are for rental. Our accommodation on the ground floor opens onto a veranda set at 45 degrees between the south and east facade. It is orientated in the diagonal axis of the garden on the side of the old garage and sheds in ruin. The veranda is an interior transitional garden between the living room and the outdoor space. The planting located on the entire side of the glacis facade in the continuity of the composition blur the border between the interior and the exterior. The rear facade was redesigned to create terrace with plant containers to each other. Soissant says, the garden facing south was modeled on the base made of all the materials from the demolition of the rear facade and the garage, then covered with a good layer of arable soil, earth support walls made with old sidewalk slabs and concrete blocks assembled like dry stone walls evoke the natural strata of rock pills. Soissant said, each space in the house gives off the different ambience. The dining room is built around a large table in the center of the annex mebel. Just above another small lamp completes the intimate atmosphere. At the mealtime, the dishes are arranged of the onyx of its over the wood fire, evoking times immemorial. Face lighting is then done in the best condition through helping to create warm human relationships. Isn't that the essential role of the architects? Stage the lives of the occupant of the architectural space to create harmonious relationship between everyone. How can we understand then that many architects flood us with spotlights integrated into the ceiling, whose light shower makes face ugly by making the shadows on the eyebrows and noses? Soissant 18. The sanitary applies, even a remarkable well-designed one, never makes me dream. It retains a personal hygiene, nothing more. To design the ideal place for washing, the references of the river immediately shoot out to me, and it is absence of the waterfall, the trickle of water coming from a source under the foliage in the most suitable model butter at my ablutions. These natural places are not accessible to me. I sought to evoke them through the shapes given to the bath tube until made up of an assembly of different layers of multiplex. Soissant 19. There was no place for taps into the environment. They were replaced by various stones regulating the water supply. The choice of flow direction at the water discharge valve. The bath tube is designed to accommodate a couple, or more precisely, our couple, since all the dimensions were taken from the first model dug in the sand by the sea. I wanted to perfectly adapt the bath tube to the anatomy of our two bodies, place head to head in order to ask a little water as possible. And to the end, I want to give us one quote taken from Richard Buckminster Fuller. You can't change reality by fighting it. To change this, we need to come up with a new model that we will make the old one obsolete. Thank you very much. Thank you very, very much.
Merci beaucoup pour cette excellente traduction.
Merci beaucoup, Luc. On est en train de finir notre conférence. Merci que tu peux montrer votre diapo et que je peux expliquer un petit peu votre idée, votre imaginaire. Alors, merci beaucoup. Je vais écrire vos emails. On va parler par email, OK? Thank you very, very much. Merci. Merci beaucoup. Merci. Au revoir.
Merci
Au revoir.
beaucoup. Au revoir.
Thanks.
Thank you very much. It was the last presentation. Thank you, Kinga, for supporting our guest. And we may assume that this ideological vision for searching something that is ideal is a kind of our discussion, let's say. It opens to the futuristic ideas. So let's sum up a little bit. But before that, I would like to invite Mr. Alex Baranowski from National Union of Architects of Ukraine. Thank you. Okay, so let's... Okay. So I will give you my microphone, or maybe we can check if some of these are not. Maybe it's better. Ah. Okay, do you need the microphone, or we can use it? Okay, thank you.
Good day, dear ladies and gentlemen, our colleagues. Thank you for the invitation and the conference. Thank you very much, the organization, for their important work to make this event happen, and partners who provided funds. The consequences of military actions on the territory of Ukraine are reaching critical volumes. More and more people are losing their homes and need to create a full-fledged living environment. Thank you for being with us. As this war is a joint struggle against human democratic values, against barbaric racism. Ukrainians are fighting for it at the fronts, at the cost of their lives, and in the rear and during all attacks Russian aggressors to destroy the Ukrainian nations. On behalf of the National Union of Architects of Ukraine, we express our respect and gratitude for the great contribution to the development of cooperation between our countries. This made it possible to deepen the exchange of information between us and to develop the future direction and European integration in the reconstruction of Ukraine. We wish you and all architects the realization of their creative potential and professional success. Thank you so much.
Thank you very much. The microphone.
Mogę po polsku?
Yes, sure.
Szanowni Państwo, w imieniu prezesa Stowarzyszenia Architektów Ukrainy chciałbym przeczytać list adresowany do rektora Politechniki Warszawskiej, profesora Krzysztofa Zaręby. Szanowny Panie Rektorze, w rocznicę Międzynarodowej Konferencji Architektura Wyzwań, Pomoc Ukrainie, która odbyła się w Warszawie, pragniemy wyrazić nasz szacunek i jeszcze raz podziękować za zaproszenie do udziału w konferencji. Szczególne podziękowania należą się profesorowi Annie Wierzbickiej, która była główną siłą napędową Komitetu Organizacyjnego Konferencji. Pawilion w Parku Łazienkowskim, projekty dotyczące mieszkalnictwa dla uchodźców we Lwowie, program wsparcia ukraińskich uczestników konferencji zrealizowany z jej inicjatywy. Trudno wymienić wszystkie jej zasługi w rozwoju współpracy przedstawicieli środowiska architektury Polski i Ukrainy. W imieniu Narodowego Stowarzyszenia Architektów Ukrainy serdecznie dziękujemy za zaproszenie do udziału w konferencji Architektura Wyzwań, Materiały dla Przyszłości. Wyrażamy nadzieję na rozwój współpracy pomiędzy Stowarzyszeniem Architektów Ukrainy i Politechniką Warszawską w przyszłości. Z wyrażami szacunku prezes Stowarzyszenia Architektów Ukrainy Aleksander Czyżewski. Jutro ten list będzie przekazany do pana rektora. Jeszcze raz dziękuję.
Let me translate maybe the intention of the letter. The letter is devoted to the, it will be passed to the rector of Politechnika Warszawska of Warsaw University of Technology, and it says that the association wants to express a great attitude, and they are very thankful, especially to Professor Anna Wierzbicka for the organizing the whole event, and they hope to cooperate in the future, more or less. Thank you very much. Okay, and now we have to ask our spiritus movens of this event to say a few words to summarize up.
Thanks for all the participants who stayed to the end, because it's not easy to be here. I know it's struggling, but I think the conference was very fruitful, and I hope we learn a lot, and we had opportunity to talk to each other, to exchange contacts, to know each other, because without speaking, without relation, we cannot do anything. I like to thank all the people who helped me a lot. I see 3 of them in this room. I would like to thank especially Maria Arno, who was really involved and sending you emails on the time from day to night. Without her help, we wouldn't be here. I would like to thank a lot Kinga Zinowiec, who was in charge of main key speakers, and she really did a lot of work, and we were discuss about who to invite, but her, I think without her wouldn't be so much interesting people. I would like to thank Commission, all the people who help us, Justyna and Ania Tofiliuk in the back, who helped me on the last scene to make this conference, and without all the people, because it's about 20 people who were working so we can meet here, this conference wouldn't appear. And I hope next year, the same time, in the same building. First day and Łazienki Królewskie. Second day here, we will meet again. Now we are working on the other topic. We are working to get the money, but if you start something good, the idea will grow up. So please support us, please come, let's talk. And now we have a private organization. If any one of you want to come with us and see the old town, we can go for the coffee. It's not very far. We are architects. We can explain you if you're first time in Warsaw. We are in the beautiful place in Saloon of the Warsaw. This road was, this way was designed by Domaracki, the professor from our faculty. Here's Paweł Trębacz, who is now taking a charge of and develop his idea and his own idea, yes. And we can talk. So I invite you all for the excursion, yes, just a private excursion, and see you again next year. And thank you all for stay to the end, because it's really a big group, yes. So, I didn't mention Michał Gołębieski on the end. He helped us a lot with taking care of the projector. And here is not Professor Kuczyński. I have to mention him because he was my mentor for many years. I made a PhD by his promotion and the diploma, and he helped us with this beautiful graphic. It's a brick which is made of the mushroom, yes, the mushroom brick, and it make our all the conference design, and it was very important for us. And if you can see, we have a cycle, so the books are the same, we name them, and I hope this cycle will come every year. We change the topics, we can meet, we have to discuss. So thank you all, and meet again next year. Okay, so wait. Hubert told me two more information. One information is Maciej Kaufman, architect for our team, tomorrow at 7 o'clock in the evening, so 19, yes, 7 o'clock in the evening, 7 p.m. He will make an excursion for all the people who want to see the Kopiec Powstania. This is Bartycka, number 26. It's beside the opposite side of Castorama. Please come, because it's a very good project which had a lot of awards. I cannot mention how many, a lot. And it's very interesting to see it in the reality. And the second information tomorrow, it's 10 o'clock. We will open the exhibition of the Ukraine project for refurbishing. Iwano-Frankowski competition. My team from the faculty won the third prize, so be there. And we are making with collaboration with Ukraine architects. I hope it will come true. Our student helped to manage to do that. So this is not the end, this is the beginning. And on the end, I like to thanks all the friends from Ukraine. We hope next year we can invite you again, manage to host you here in Warsaw and to be in touch. And last thing that I want to say, I hope we will meet here and the Ukraine will be free country. Let's go. It's over.